Close your eyes and let your breathing soften. Tonight we drift back more than 60 million years to a world remade after fire and silence. Dinosaurs are gone, but life stirs again, forests rising, mammals awakening, oceans filling with new giants. Let the story unfold gently, a calm journey into Earth's quiet rebirth after catastrophe. 66 million years ago, Earth was a thriving, restless planet. Vast forests stretched across continents, inland seas shimmered under warm skies, and dinosaurs of every size ruled the land. Giant predators stalked the plains, while herds of horned and duck-billed species thundered across floodplains in migrations that seemed eternal. In the oceans, mosasaurs and plesiosaurs patrolled the depths, while the skies belonged to pterosaurs with wingspans wider than a small airplane. It was an age of power and dominance, an era where life seemed invincible, and then, in an instant, it ended. A rock from space, roughly 10 kilometers across, entered Earth's atmosphere at tens of kilometers per second. The asteroid had been traveling for millions of years, silent and unseen, until the trajectory intersected with our planet. As it slammed into the shallow waters near what is now the Yucatan Peninsula, it unleashed energy equivalent to billions of nuclear bombs. The impact crater, still preserved today as the Chicxulub crater, measures more than 180 kilometers wide and nearly 20 kilometers deep. For Earth, it was not just a collision. It was an apocalypse. The first moments were blinding. The shockwave rippled outward faster than sound could travel, vaporizing rock, water, and anything living within hundreds of kilometers. The air itself turned to fire, igniting forests instantly. Debris hurled into the sky rained back down, glowing like meteors, heating the atmosphere so intensely that entire continents may have smoldered at once. Dinosaurs grazing peacefully one moment would have been incinerated the next. Across the Gulf of Mexico, tsunamis hundreds of meters high crashed against shorelines, tearing ecosystems apart. Within minutes of impact, Earth's surface was transformed into a world on fire. But the devastation did not end with the blast. The true killer was the sky itself. As the asteroid's debris mixed with vaporized rock and sulfur from the impact, it was blasted into the upper atmosphere. There, it spread like a global shroud. Sunlight, the lifeblood of photosynthesis, was cut off. For months and possibly years, Earth lay under a choking canopy of ash and dust. Daylight dimmed to twilight. Temperatures plunged. Forests withered. Oceans cooled. The food web collapsed from its foundation upward. Plants died in mass, followed by the herbivores that fed on them, followed by the predators that fed on those herbivores. The evidence for this catastrophic darkness is written in the rocks. Around the world, geologists have found a thin layer of clay, rich in iridium, a metal rare on Earth but common in asteroids. This iridium layer marks the boundary between the Cretaceous and the Paleogene, a global scar from the impact. Within that boundary, scientists also find shocked quartz, spherules of glass formed from molten rock, and soot from worldwide fires. Together, these remnants tell a story of destruction so thorough that 75% of species on Earth vanished. The great non-avian dinosaurs, the towering sauropods, the fierce tyrannosaurs, the armored ankylosaurs, disappeared forever. In the oceans, plankton populations collapsed, and with them the entire marine food chain. Mosasaurs, plesiosaurs and ammonites perished. Coral reefs crumbled. On land, entire lineages of plants vanished. Large animals across the globe succumbed to starvation, heat, and cold. The extinction spared no region, no ecosystem. It was one of the 5 greatest mass extinctions in Earth's history, and perhaps the most dramatic in its suddenness. Yet amid this chaos, some creatures endured. Small mammals, burrowing reptiles, amphibians, and certain species of birds survived the cataclysm. Their small size, flexible diets, and ability to shelter in the ground or water gave them a resilience the giants lacked. Crocodiles, for example, could hunker down in rivers and lakes, surviving months without food. Mammals, once shadow dwellers under the reign of dinosaurs, scurried through the ruins, eating seeds, insects, and carrion. These survivors inherited a world forever altered. The image of Earth during those years after impact is haunting. Imagine standing under a sky that never clears, where the sun is no more than a dim red glow. Imagine breathing air heavy with smoke and dust, the smell of burnt forests everywhere. Rain would have fallen as acid, poisoned by sulfur compounds lofted into the atmosphere. Rivers clogged with ash. Oceans turned toxic with chemicals unleashed from burning rock. Even for the survivors, life was precarious. Every day a fight for existence in a world stripped to its bones. But even as the extinction unfolded, seeds of renewal were planted. The same fires that reduced forests to ash also fertilized the soil. Ferns, hardy and opportunistic, were among the first plants to return. They spread across the blackened landscapes, forming fern prairies that carpeted the ground where giant forests had stood. This fern spike, visible in the fossil record, is one of the earliest signs of recovery. It was life's way of saying, not everything ends. Some beginnings hide in endings. Over tens of thousands of years, the dust settled, the skies cleared, and sunlight returned. Climate stabilized, though it was cooler than before. Plants diversified again, filling empty niches. Forests regrew, this time dominated by flowering plants that had been minor players in the Cretaceous, but now surged forward. With dinosaurs gone, mammals began to expand in size and variety. Birds, descended from small theropod dinosaurs, flourished in the open skies. Earth, devastated and transformed, began a new chapter. What makes this story so remarkable is not only the scale of destruction, but the resilience of life itself. The asteroid impact was an extinction, but it was also a reset. The dominance of dinosaurs, which had lasted for more than 150 million years, ended in a single geological instant. But without that ending, the rise of mammals and eventually humans might never have happened. Our very existence is linked to the catastrophe. Every breath we take, every step we make is possible because an ancient world was destroyed to make way for a new one. To walk today in a forest, to hear birds sing, is to hear the descendants of dinosaurs that survived. To look at mammals, ourselves included, is to see the beneficiaries of that long night after the fire. Earth's history is not just a story of tragedy. It is a story of endurance, of survival against impossible odds, of beauty rising from ashes. The world on fire gave birth to the world we know. And so the Cretaceous ended not in silence, but in a thunderclap that echoed across ages. The dinosaurs did not fade gently. They were cut down in a moment of unimaginable violence. Yet life, stubborn and tireless, found a way through the darkness. From the ashes of that catastrophe came the roots of everything familiar. The world on fire became the world of birds, forests, mammals, and eventually humanity. The asteroid struck and the fires burned. But the deadliest phase of the extinction began not with flame, but with shadow. After the skies filled with dust, soot, and vaporized rock, sunlight itself was strangled. Day turned to twilight, and twilight faded into a cold, dim half-darkness that lingered for months, then years. For the creatures of Earth, it was as though the sun had abandoned them. Photosynthesis faltered within days, food webs collapsed within weeks, and life stumbled towards silence. This was the long night, the global winter that followed the Chicxulub impact, and it reshaped the destiny of the planet. Imagine waking on the first day after the fires subsided. The air is grey, the horizon blurred, the sun is a faint red ember behind an impenetrable veil, giving no warmth, no true light. The smell of charred forests hangs everywhere. Acid rain falls, burning leaves and poisoning rivers. Insects, the tireless recyclers of the biosphere, swarm over carcasses but find themselves overwhelmed by sheer abundance of death. The very rhythm of day and night, so steady for billions of years, feels broken, replaced by a ceaseless gloom. Plants were the first to feel the weight of this darkness. Without sunlight, photosynthesis halted almost entirely. Leaves withered, seeds failed to sprout, and forests collapsed. Ferns, hardy opportunists, managed to survive by spreading spores into ash-covered soil, but for most plants, the long night was fatal. Across the globe, pollen counts plummeted, a signal preserved in sediment cores that testify to the collapse of ecosystems. This disappearance of plants triggered the fall of herbivores, and their decline in turn doomed the predators. It was a chain reaction of starvation, a cascade that spared almost nothing large enough to need constant feeding. The oceans fared no better. Phytoplankton, the microscopic plants of the sea, died in massive numbers. With the base of the marine food web gone, everything that depended on it suffered. Zooplankton dwindled, fish starved, and great marine reptiles already weakened by the chaos of the impact could not endure the collapse of their world. The ammonites, once abundant and diverse, vanished entirely. Coral reefs crumbled into lifeless rubble. The long night did not distinguish between land and sea. It cast its shadow everywhere. Temperatures plunged. The dust and aerosols high in the stratosphere reflected sunlight away, creating a sudden global winter. In places that had once been warm and lush, frost settled. Ice gripped landscapes that had not known cold in millennia. Even tropical regions grew chill, and creatures adapted to warmth struggled to survive. Reptiles, dependent on external heat, slowed into lethargy. Many could not endure the sudden cold. Mammals, though small, had a slight advantage. Warm-bloodedness gave them resilience in the chill. Their ability to huddle, burrow, and conserve heat gave them a narrow foothold in a dying world. In the fossil record, this darkness is preserved not only in chemical traces, but in absence itself. The sudden drop in diversity is stark. Entire lineages disappear above the iridium layer, leaving no descendants. On land, 3 out of every 4 species perished. In the seas, it was even worse. The long night did not kill quickly, like the impact did, but slowly, relentlessly, starving ecosystems of their lifeblood. And yet, some endured. Crocodiles survived by waiting in rivers and lakes, able to endure long periods without food. Turtles retreated into mud and shells, riding out the darkness. Amphibians, living partly in water and partly in hiding places underground, persisted as well. Birds, descendants of small feathered dinosaurs, scraped by on seeds and insects. Mammals, tiny, furtive, omnivorous, found ways to feed when giants could not. They ate roots, scavenged, dug for insects, and took shelter underground. Survival was not about strength or size. It was about flexibility, adaptability, and luck. For dinosaurs, the long night was catastrophic. Large herbivores like hadrosaurs and ceratopsians starved quickly without plants to eat. Predators like Tyrannosaurus rex, already stressed by dwindling prey, perished soon after. Smaller theropods fared little better unless they had already evolved into bird-like forms with diets less dependent on fresh plants. By the end of the long night, non-avian dinosaurs were gone, their 150 million year reign cut short in a geological blink. The skies, once filled with the silhouettes of pterosaurs, grew empty. These great flyers, some with wingspans over 10 meters, had no refuge in the new world. Their fish prey had vanished, their nesting grounds scorched. Within a few thousand years they too disappeared, leaving the skies to the birds. The oceans, once ruled by mosasaurs and plesiosaurs, became graveyards. Sharks survived, resilient and opportunistic, but the great reptiles of the sea were lost forever. The long night stretched on. Estimates vary, but many scientists believe the worst of the darkness lasted months to a few years, with ecological effects dragging out for decades. For a human, this would have been unbearable. Imagine children born under a sunless sky, never seeing true daylight until they were old. For the survivors, every day was uncertain, every resource scarce. Life was reduced to its simplest task: endure until the light returned. Eventually, slowly, the skies began to clear. Dust settled into oceans and sediments. Sulfur washed out in acid rains. Sunlight returned, weak at first, then stronger, coaxing green shoots from the soil. Ferns surged across the landscapes, forming vast fields where forests had stood. Then flowering plants returned, followed by the slow regrowth of forests. But the ecosystems that emerged were not the same as before. They were reset, reorganized, and dominated by survivors who now had the stage to themselves. The long night was both an ending and a bottleneck. It pruned the tree of life with brutal efficiency, cutting away branches that had thrived for millions of years. But through that pruning, it allowed space for new growth. Mammals, once suppressed by the dominance of dinosaurs, now expanded into niches left vacant. Birds, once small and few, flourished into countless forms. Insects adapted quickly, feeding on the new plants. Crocodiles and turtles continued their ancient lineages, unchanged survivors of an apocalypse. The world that emerged was a different one, but it was alive. From the perspective of geology, the long night was brief. In a few tens of thousands of years, ecosystems rebounded. In a few million years, diversity surged again. But for the creatures who lived through it, it was endless. Days without light, months without reliable food, years of struggle. Survival was not guaranteed. The fact that anything endured is testimony to life's resilience. Today, the memory of the long night is hidden in stone and soil. The iridium layer marks its beginning. Fossil gaps mark its toll. Charcoal deposits testify to its fires, while fern spores testify to its renewal. To hold a rock from that boundary is to hold the story of Earth's darkest hours, the moment when sunlight failed and life nearly followed. And yet, we must see this darkness not only as tragedy, but as transformation. The long night ended the age of dinosaurs, but it also made possible the rise of mammals, the flourishing of birds, the eventual appearance of humans. Without the darkness, there would be no us to reflect on it. Our existence is tied to that silence, that ash, that near ending. Out of shadow, new light came, not the same as before, but enough. The long night teaches a profound truth about Earth. Endings are rarely absolute. They are thresholds, passages between one age and another. For dinosaurs, it was the end. For mammals, it was the beginning. For Earth, it was a scar, but also a reset. Life is fragile, but it is also stubborn. Even under a sky that turned against it, life held on. And in holding on, it ensured that the story would continue. When the dust settled and the fires dimmed, the world was not empty, but it was unrecognizable. The colossal dinosaurs were gone, the thunder of their herds silenced, the roars of their predators vanished into memory. The great reptilian lords of the oceans, the mosasaurs and plesiosaurs, were erased, their skeletons lying in sediments that would one day whisper of their existence. Pterosaurs, once monarchs of the sky, no longer cast shadows across ancient coastlines. Yet life, stubborn and unyielding, had not ended. Beneath the ashen canopy of the long night, in burrows, in rivers, in hidden corners of forest and swamp, the small, the quick, and the lucky endured. They were not the rulers of the old world, but they would inherit the new. The mammals, long overshadowed by the dinosaurs, were among the quiet survivors. In the Cretaceous, they had lived like fugitives, scurrying through undergrowth, hunting insects by moonlight, stealing seeds and eggs in the hours when giants slept. Most were no larger than a rat or rabbit, some equipped with sharp teeth for omnivory, others adapted to insect-eating diets. Their size, once a limitation, became their salvation. Small bodies needed less food, and their ability to burrow or nest underground provided shelter from fire, cold, and predators. In a world stripped bare, where plants had died and herbivores vanished, these mammals could scrape survival from roots, insects, carrion, and anything else that remained edible. Birds, too, survived, though not all of them. The great toothed seabirds of the late Cretaceous disappeared, their dependence on marine food chains proving fatal. But smaller, more versatile birds endured. These were descendants of small theropod dinosaurs, feathered creatures whose resilience lay in their ability to eat seeds, insects, and anything they could glean from devastated landscapes. Seeds, in particular, acted as time capsules of energy. Even when plants died, buried caches of seeds could nourish birds through the long night. Their light, hollow bones, inherited from their dinosaurian ancestors, allowed them to fly away in search of better patches of survival, giving them mobility in a fractured world. Their voices became the first new songs in the silence after the extinction. Crocodiles, ancient as the dinosaurs themselves, also survived. These creatures had always been masters of patience. Cold-blooded, capable of long fasting, they could wait in rivers and lakes for months with minimal food. During the extinction, when most large prey animals disappeared, crocodiles endured by feeding opportunistically on fish, carrion, or whatever stumbled into their waters. Their armored bodies, powerful jaws, and aquatic lifestyle insulated them from many of the worst effects of the collapse on land. Even today, their lineage seems frozen in time, a reminder of resilience shaped by millions of years of adaptability. Turtles, with their shells and simple diets, were another lineage that passed through the bottleneck. Aquatic and semi-aquatic species could shelter in mud, hibernate through lean seasons, and survive on limited food. Their armored shells made them less vulnerable to predators, while their slow metabolisms allowed them to endure where more energy-hungry animals perished. Fossil evidence shows turtles persisting through the boundary, their lineages continuing almost unchanged from before the impact. In a sense, turtles represent the idea that survival does not always belong to the most innovative, but sometimes to the most consistent. What united these survivors was not dominance, but adaptability. The giant animals of the late Cretaceous were specialized, locked into ecological roles that required abundant food and stable climates. When those vanished, their size and specialization became fatal burdens. The survivors were generalists, opportunists, creatures able to live off scraps and endure extremes. They hid, they scavenged, they adapted. They were not rulers, but they endured long enough to inherit a quieter, emptier world. The fossil record tells this story in fragments. Mammal teeth appear in sediments above the extinction layer, showing sudden diversification after the dinosaurs' fall. Bird fossils become more common, representing new species that spread across continents. Crocodile and turtle remains show continuity, evidence that their ancient forms persisted. Paleontologists describe this as an evolutionary bottleneck. Life squeezed through a narrow gate, with only certain lineages making it to the other side. And once through, they began to expand, filling ecological spaces left vacant by the fallen giants. But survival was not easy. Imagine the first years after the impact. The forests were gone, reduced to charred stumps. Rivers ran thick with ash. The air was cold, the light dim. Mammals huddled in burrows, emerging cautiously to scavenge insects or seeds. Birds scratched in the soil for the buried caches of plants that had died. Crocodiles floated in muddy waters, snapping at fish that had somehow survived. Turtles withdrew into shells, conserving energy until better times came. Every day was a gamble, every bite of food a reprieve. Survival was not guaranteed. It was earned, moment by moment. Over time, the skies cleared. Ferns returned first, carpeting the land in green. Birds feasted on the seeds of new plants, while mammals dug for roots and shoots. Insects rebounded, providing food for opportunists. With ecosystems rebuilding, the survivors began to thrive. Mammals, once confined to small forms, started to diversify into larger shapes, taking over roles once held by dinosaurs. Birds, freed from aerial competition with pterosaurs, expanded into countless varieties. Crocodiles and turtles continued as they always had, ancient guardians of survival strategies that needed no change. The survival of these lineages shaped everything that came after. Without mammals enduring in the shadows, there would have been no primates, no humans. Without birds, the skies might have remained empty, robbed of song and flight. Without crocodiles and turtles, ecosystems would have lost some of their oldest and most enduring predators and herbivores. The world that emerged after the extinction was not a diminished version of the old, but the foundation of a new era. The survivors carried forward the spark of life into a future where it could blaze again. The lesson of this chapter in Earth's story is not about dominance, but resilience. The giants fell because they could not bend, but the small endured because they could. The mammals, birds, crocodiles and turtles remind us that survival is not always about strength. Sometimes it is about hiding when the world burns, waiting when the world freezes, and eating whatever can be found when abundance disappears. In their shadows, life paused, but did not end. From their shadows, the age of mammals, the age of birds, and ultimately the age of humans would emerge. To imagine survival in those years is to imagine silence. No thunder of dinosaur herds, no cries of pterosaurs, no mosasaurs breaking waves. Only the rustle of small mammals in the undergrowth, the cautious calls of birds in the dawn gloom, the splash of a crocodile in a muddy river. Life whispered instead of roared. But those whispers were enough. They carried Earth through the darkness, through the long night, into light once more. The silence after the cataclysm was not permanent. Though the skies had darkened, though forests had burned and seas had turned cold and barren, life did not surrender entirely. From the blackened ground, from the soil laced with ash and bone, came the first green shoots of renewal. What seemed at first like a graveyard for the planet was, in fact, a seedbed for rebirth. The story of Earth after the dinosaurs is not only one of destruction, it is one of recovery, a tale of resilience told in roots, spores, and leaves. Ashes became soil, and from that soil rose the world we now know. In the immediate aftermath of the asteroid strike, landscapes were stripped bare. Charcoal covered the ground, trees stood as skeletons, and fertile soils had been scoured or poisoned by acid rain. Yet some plants were already prepared for such devastation. Ferns, with their hardy spores, were the first to return. They are among the oldest plants on Earth, predating flowering plants by hundreds of millions of years, and their survival strategies are built for catastrophe. Spores are tiny, easily carried by wind, able to colonize devastated land quickly. Within years of the impact, ferns spread across continents, forming vast carpets of green over the ruins of the old world. Paleobotanists call this the fern spike, a sharp surge in fern spores preserved in the fossil record. It is one of the clearest signs of recovery, a botanical fingerprint of life's stubbornness. The fern fields were not forests, but they were enough. They held soil in place, prevented erosion, and provided the first steps of a new food chain. Insects returned to feed on the fronds, birds and mammals fed on the insects, and slowly ecosystems began to reassemble. These fern prairies were stopgaps, temporary landscapes, but they were critical bridges between collapse and renewal. Without them, the Earth might have remained barren for far longer. As time passed, flowering plants began to reassert themselves. Before the asteroid impact, angiosperms, plants that reproduce through flowers and fruits, had already begun spreading across the world, competing with conifers and cycads. The extinction cleared space for them to dominate. Their seeds, protected within fruit or hard shells, often survived in the soil through the long night. When the skies cleared and sunlight returned, these seeds germinated. Forests of flowering plants began to rise, reshaping habitats in ways that would ripple through millions of years of evolution. The return of forests was uneven. In some regions, trees sprouted within decades. In others, recovery took centuries. But the trajectory was clear. Ash-enriched soils proved fertile for new growth. Rain carried minerals into the ground, feeding root systems. With time, landscapes once reduced to wastelands transformed into mosaics of flowering trees, shrubs, and undergrowth. The diversity of these new forests was different from the Cretaceous ones they replaced. Many gymnosperms, cone-bearing trees, declined, while angiosperms surged forward. The forests of the Paleocene, the epoch after the extinction, were lush with broad-leaved trees, fruit-bearing species, and dense canopies that nurtured entirely new kinds of life. The rise of flowering plants had profound consequences. Fruits and seeds offered concentrated packets of energy, shaping the diets and behaviors of animals. Birds thrived in these new forests, feeding on seeds and dispersing them further. Mammals, too, benefited from the bounty of fruits, nuts, and vegetation. The coevolution between plants and animals accelerated. Plants produced sweeter fruits to attract animals that would spread their seeds, while animals developed specialized teeth and digestive systems to consume them. What began as survival in the shadow of disaster blossomed into one of the greatest evolutionary partnerships in Earth's history. Grasses, though not yet dominant, also began their slow rise after the extinction. Early grasses crept into open spaces left between forests, paving the way for the vast grasslands that would one day shape mammalian evolution. In the immediate aftermath, these grasses were minor players, but their presence signaled the deep transformations yet to come. The soil itself changed. Where once it had been littered with dinosaur dung and the trampled remains of ancient forests, it was now enriched with ash, minerals, and the remains of countless plants and animals killed in the catastrophe. Decomposers, fungi, bacteria, and insects turned this devastation into nourishment. Fungal spores exploded in abundance after the extinction, breaking down dead organic matter into fertile ground. What had been a graveyard became, layer by layer, a garden. The pattern of renewal can be seen clearly in fossil evidence. In North America, once home to great herds of ceratopsians and hadrosaurs, fern fields gave way to forests of flowering plants. In Europe, tropical forests of palms and magnolias spread. In South America, early rainforests began to appear, rich with diversity. Even in polar regions where darkness and cold lingered, hardy plants pushed their way back into existence. It was not uniform, but it was relentless. Life refused to give up its grip. For the animals that survived, these changes offered both challenges and opportunities. Mammals, once small and secretive, now found new food sources in seeds, nuts, and fruits. Birds diversified rapidly, some becoming seed-eaters, others insectivores, and still others hunters in the growing forests. Crocodiles and turtles adapted to wetlands enriched by new plant life. Insects flourished, evolving alongside the plants that fed them. Each step of botanical recovery created new niches, and evolution raced to fill them. The forests that rose in the Paleocene were not quiet. They were filled with the calls of birds, the rustle of mammals in the undergrowth, the hum of insects among flowers. Where once tyrannosaurs and triceratops had battled, now small mammals foraged, and giant flightless birds stalked through the ferns. The world was different, smaller in its players but no less alive. It was a different kind of grandeur, one defined not by giants, but by diversity. What makes this transformation even more profound is its speed in geological terms. Within a million years of the impact, ecosystems had stabilized. Within 10 million years, biodiversity had surged to levels rivaling the late Cretaceous. Entirely new lineages of mammals, birds, and plants had emerged, reshaping the biosphere. The ashes of the extinction had indeed become soil, and from that soil had risen a new earth. The lesson of this recovery is one of resilience and transformation. Destruction and creation are intertwined in Earth's story. The asteroid ended the reign of the dinosaurs. But it also opened the stage for mammals and birds. It burned forests but fertilized the ground for flowering plants. It plunged the world into darkness but set the conditions for a new dawn. The ashes of catastrophe were not the end. They were the raw material for beginnings. Today, when we walk through a forest, when we hear birdsong or taste fruit, we are witnessing the legacy of that renewal. The ecosystems we depend on are descendants of the recovery that followed the extinction. Our very existence is tied to those first shoots of fern, those first flowering trees, those first soils reborn from ash. Without them, the chain of survival that led to primates and eventually to humans might never have formed. The image of ashes becoming soil is more than metaphor. It is the literal truth of Earth's resilience. What was destroyed became the foundation of what came next. The story of life is not linear, but cyclical, marked by collapse and renewal, by fire and regrowth. In the wake of the asteroid, life clawed back, not by returning to what it was, but by inventing something new. The world that rose from the ashes was not the same as the one that fell, but it was no less vibrant, no less wondrous. From ruin came richness, from silence came song, from ashes came soil, and from soil came life again. When the great thunder of the non-avian dinosaurs faded, when tyrannosaurs and triceratops no longer stamped their mark upon the earth, it might have seemed that the age of the reptiles had ended in silence. The skies, once crossed by immense pterosaurs with wingspans as wide as small airplanes, stood momentarily empty. The world was stripped bare, its ecosystems fractured, its great predators erased. And yet among the ruin, survivors stirred. They were small, feathered, and largely overlooked. But in the absence of giants, they found space to stretch their wings. These were the avian dinosaurs, the creatures we now call birds. Their story after the extinction is one of seizing opportunity, of diversifying into the skies and landscapes left vacant, of becoming masters of niches that had never before existed. This was the beginning of the age of birds. Long before the asteroid struck, birds already existed. They were the descendants of small theropod dinosaurs, kin to velociraptors and other feathered hunters of the Mesozoic. Some of these early birds had teeth, long bony tails, and clawed hands on their wings. They were not yet the sleek flyers of today, but their lineage was clear. They were dinosaurs, adapted for the air. When the catastrophe struck, most vanished along with their larger relatives. Yet a few groups endured, and those survivors carried forward traits that allowed them to thrive. Light bones, feathers that provided both insulation and flight, beaks that could specialize for many diets. These were not just features, they were survival tools. In the first years after the asteroid, the skies were dim, the forests burned, and food was scarce. But birds had one enormous advantage over many other creatures: seeds. Seeds buried in the soil or preserved within tough casings survived the long night. Birds that could crack and eat them endured when herbivores starved. Fossil evidence shows that some of the earliest post-extinction birds belonged to groups with strong seed-crushing beaks. These humble granivores were the bridge across the catastrophe, the link between the Mesozoic and the world to come. As sunlight returned and plants began to regrow, birds spread quickly. They were highly mobile, able to fly from one patch of green to another, carrying seeds in their bellies and dispersing them across scarred landscapes. In this way, birds did not simply survive, they became agents of recovery. Their movements helped shape the return of ecosystems, creating new forests and spreading flowering plants. This partnership between birds and plants deepened across millions of years, laying the groundwork for the biodiversity we see today. The absence of pterosaurs opened vast aerial niches. For more than 150 million years, these giant flying reptiles had dominated the skies. But with their extinction, birds inherited the open air. They diversified with astonishing speed. Some became insect hunters, darting through fern fields and young forests. Others adapted to wetlands, fishing in shallow rivers where reptiles had once ruled. Some grew larger, taking on the roles of terrestrial predators abandoned by dinosaurs. Within a few million years, birds had expanded into forms as varied as the ecosystems they inhabited. The fossil record of the Paleocene and Eocene epochs reveals strange and magnificent avian experiments. There were enormous flightless birds, some over 3 meters tall, with heavy beaks that crushed bone. In South America, these terror birds became apex predators, filling the void left by carnivorous dinosaurs. Their skeletons show powerful legs for sprinting and heads equipped with hooked beaks that could tear flesh. For millions of years, they stalked plains and forests, unmatched in their ferocity. Smaller flightless birds evolved too, filling herbivorous roles in grasslands and forests. The age of birds was not confined to flight. It included a spectrum of forms, from the tiny hummingbird-like ancestors that sipped nectar to giants that shook the ground when they ran. Meanwhile, in aquatic realms, birds pioneered new lifestyles. Early penguins, some as tall as humans, dove into oceans, using wings as flippers to chase fish. These birds thrived in southern seas, their fossils found in what is now New Zealand and Antarctica. Unlike the pterosaurs they replaced, penguins were expert divers, filling niches that marine reptiles had abandoned. Other waterfowl evolved to skim lakes and rivers, feeding on plants and invertebrates. The diversity of beaks, from sharp spears to broad sieves, testifies to their adaptability. Songbirds, which would one day become the most diverse group of vertebrates on Earth, began their rise in these early epochs. Their voices, developed for communication in dense forests, transformed the soundscape of the planet. Where once the cries of dinosaurs and the screeches of pterosaurs echoed, the dawn chorus of birdsong emerged, a symphony of survival. The ability to produce complex calls gave birds social advantages, enabling them to form flocks, defend territories, and court mates with elaborate songs. It also made them endlessly adaptable, allowing different species to exploit niches in every environment. Flight gave birds unmatched mobility in the reshaping world. As continents drifted and climates shifted, they spread into every region, from tropical forests to polar shores. Their eggs, lightweight and easily hidden, allowed rapid colonization. Their feathers, versatile and insulating, let them endure a range of climates. The age of birds became global, not confined to one ecosystem, but encompassing the entire Earth. Fossils show them in every region, their diversity exploding within 10 million years of the extinction. Their success was not inevitable. Many lineages faltered or disappeared. Some birds retained teeth and clawed wings, but these archaic traits were gradually abandoned in favor of lighter, more specialized designs. Evolution favored sleekness, efficiency, and adaptability. The birds we see today are the product of this long experimentation, survivors of countless trials in an Earth still healing from catastrophe. In ecological terms, birds became the glue of recovery. They were pollinators, seed dispersers, insect controllers, and scavengers. They helped stabilize ecosystems by occupying roles once filled by dinosaurs. They made forests richer, wetlands more complex, and plains more dynamic. Their ability to move across landscapes meant that they connected habitats, spreading life from one patch to another. In doing so, they became essential architects of the biosphere's rebirth. The age of birds also altered the course of mammalian evolution. Mammals and birds competed for similar niches: insects, seeds, small vertebrates. The presence of predatory terror birds in South America, for example, delayed the rise of mammalian carnivores there until later connections with North America shifted the balance. In forests, the dispersal of seeds by birds created habitats that mammals later exploited. Evolution became a conversation between these two rising groups, shaping one another through competition, cooperation, and shared ecosystems. From an evolutionary perspective, the radiation of birds after the extinction is one of the most remarkable examples of adaptive success. In less than 20 million years, they filled the skies, the trees, the waters, and the ground. They became not just survivors, but innovators, reshaping the Earth in their image. Their diversity today, nearly 10,000 species, reflects the opportunities they seized in those crucial early epochs. Every pigeon, eagle, parrot, and sparrow is a descendant of the few lineages that endured the asteroid's impact. The symbolism of this transformation is striking. Dinosaurs, once seen as symbols of dominance and extinction, never truly vanished. They shrank, feathered, and adapted into forms that outlasted their giant relatives. Birds are living dinosaurs, reminders that evolution does not stop with disaster, but flows through it, reshaping life into unexpected forms. Every time we hear birdsong, we are hearing the voices of dinosaurs that refuse to die. Every feather is a thread tying us to the Mesozoic, proof that the age of dinosaurs continues in subtler, more delicate ways. In modern skies, birds dominate almost every ecosystem. They soar over mountains, dive into oceans, skim deserts, and thrive in cities. Their presence is so ubiquitous that it is easy to forget their extraordinary history. But the roots of that dominance lie in the age that began after the asteroid, when they spread into niches abandoned by the fallen. They filled the silence with wings, with song, with presence. The age of birds was not just a continuation of life, it was a reinvention of it. What happened after the dinosaurs went extinct was not emptiness but opportunity. Birds, inheritors of a lost world, became the agents of a new one. They are both past and present, both survivors and pioneers. Their rise reminds us that extinction is not only about endings, it is also about beginnings. The asteroid cleared the stage, and the birds took flight. The world has never been the same since. In the shadow of the extinction, when the world was hushed and the giants were gone, another story began to unfold. For more than 150 million years, mammals had lived small lives, surviving in the margins of a world dominated by dinosaurs. They crept through the underbrush, scurried along branches, and tunneled into the soil. They hunted insects at night, hid from predators by day, and never dared to rival the rulers of the age. They were clever, warm-blooded, adaptable, but they were constrained by size and opportunity. Then the asteroid fell, the thunder lizards perished, and silence settled. Into that silence, mammals stepped forward. The earliest mammals to inherit the Earth after the extinction were small, barely larger than rats or rabbits. Some had long snouts and sharp teeth for eating insects. Others had strong jaws for chewing seeds and plants. A few were semi-aquatic, like early relatives of otters, while others lived arboreal lives in the fragile forests regrowing from ash. Their diversity was not obvious at first, but the seeds of potential were there. Freed from the constant pressure of dinosaur competition, mammals began to experiment. They no longer had to remain tiny and cautious. For the first time in millions of years, they could grow larger, explore new diets, and inhabit roles that had been locked away from them. The Paleocene epoch, the first chapter after the extinction, was a quiet but critical time for mammals. During these 10 million years, they spread across the world, filling landscapes once roamed by hadrosaurs, ankylosaurs, and tyrannosaurs. Fossils show the rise of groups that would later give rise to familiar creatures. The earliest ancestors of primates, hoofed mammals, and carnivores. Some were strange, with teeth shaped like nothing alive today, or body plans that defy easy comparison. The absence of dinosaurs allowed mammals to take evolutionary risks, producing forms that pushed the limits of adaptation. It was a time of experimentation, a grand rehearsal for the explosion of diversity to come. By the Eocene epoch, around 56 million years ago, the experimentation had blossomed into full-scale radiation. Mammals exploded in form and size, from mouse-sized insectivores to creatures the size of modern horses, camels, and elephants. Some evolved long legs for running in open fields, while others developed grasping hands for climbing in dense forests. Some became predators, their teeth sharpened into fangs, and their bodies built for speed. Others became grazers, their molars adapting to grind tough vegetation. Within 10 to 20 million years of the asteroid, the Earth was filled with mammals of every shape and size, a panorama of forms unimaginable in the age of dinosaurs. The rise of ungulates, hoofed mammals, was especially significant. They diversified into early forms of horses, deer, and antelope, shaping ecosystems as grazers and browsers. Their ability to process plant matter efficiently allowed them to thrive in the flowering forests and meadows spreading across the globe. From them would eventually come the herds that thunder across savannas and grasslands. At the same time, carnivorous mammals began to evolve alongside them. Creodonts, now extinct, were among the earliest mammalian predators, prowling forests and plains with sharp teeth designed for slicing flesh. These hunters filled the role left vacant by dinosaurs like raptors and tyrannosaurs, ensuring that ecosystems regained their balance of predator and prey. Some mammals turned toward water, beginning an extraordinary evolutionary journey that would culminate in whales, dolphins, and seals. Fossils of early whale ancestors, such as Pakicetus and Ambulocetus, reveal creatures that still walked on land but hunted in rivers and seas. Over millions of years, their descendants would leave land entirely, becoming giants of the oceans. The return of mammals to aquatic life was not simply survival, it was reinvention, a bold move into niches dinosaurs had never fully occupied. Other mammals turned skyward. While birds had already claimed the skies, mammals began gliding through forests. Early relatives of flying squirrels and bats experimented with membranes stretched between limbs. By the Eocene, true bats had appeared, capable of powered flight. They hunted insects at night, complementing the roles filled by birds by becoming masters of the nocturnal air. This diversification of locomotion, running, climbing, swimming, flying, made mammals one of the most adaptable groups on Earth. Primates also began their story during this time. Small, tree-dwelling mammals with grasping hands and forward-facing eyes emerged in the Paleocene and Eocene forests. Their ability to navigate branches, use depth perception, and manipulate objects laid the foundation for the later evolution of apes and eventually humans. They were not dominant in their day, but their survival strategies, social living, intelligence, dexterity, would become decisive millions of years later. The rapid expansion of mammals after the extinction was not without challenges. Climate shifts during the Paleocene and Eocene forced constant adaptation. Periods of global warming expanded tropical forests across continents, while later cooling created grasslands and open plains. Mammals followed these changes, their bodies and diets reshaping to fit new environments. Their adaptability became their greatest strength. Where dinosaurs had specialized and fallen, mammals diversified and thrived. Fossil beds from this era reveal astonishing creatures now long vanished. Titanoboa, a massive snake more than 40 feet long, hunted in Paleocene wetlands alongside giant turtles and crocodiles. Mammals such as Andrewsarchus, a wolf-like predator the size of a horse, roamed coastal regions. In South America, isolated from other continents, mammals evolved into unique forms, including massive flightless birds that acted as apex predators. Each continent told its own story of mammalian innovation, shaped by geography, climate, and opportunity. By the Oligocene epoch, around 34 million years ago, mammals had firmly established themselves as the rulers of the Earth. Some had grown to enormous sizes, rivaling the bulk of the dinosaurs they replaced. Paraceratherium, a hornless rhinoceros, stood nearly 16 feet tall at the shoulder and weighed as much as 20 tons, making it one of the largest land mammals ever to exist. Elephants, rhinoceroses, and other giants emerged, proving that mammals could achieve colossal size once again when ecological conditions allowed. From the shadows of the extinction, they had risen to claim the mantle of dominance. The success of mammals was tied not only to their bodies, but also to their behavior. Unlike reptiles, which rely on external heat, mammals are warm-blooded. This allowed them to remain active in cooler climates and to expand into regions that reptiles could not easily colonize. Their fur offered insulation, their varied diets offered flexibility, and their social behaviors provided advantages in hunting, protection, and raising young. These traits, combined with their rapid reproductive cycles compared to dinosaurs, gave mammals a speed of adaptation that proved decisive. The age of mammals, sometimes called the Cenozoic era, was not simply a replacement of dinosaurs with new giants, it was a reimagining of life on Earth. Mammals did not replicate the dinosaurs' forms, they invented their own. They explored every possible ecological role, from tiny shrews tunneling through soil to whales diving into the depths of oceans. They became the defining group of animals on the planet, shaping ecosystems and landscapes in ways that still define our world today. For humanity, this story is personal. Our existence is the direct result of mammals stepping forward after the extinction. If dinosaurs had remained dominant, mammals may never have grown beyond their tiny, nocturnal forms. The asteroid cleared the path, but it was adaptability, resilience, and innovation that allowed mammals to seize it. Every species of mammal alive today, from lions to whales to bats to humans, carries the legacy of those small survivors who endured the long night and expanded into the daylight. The symbolism of this rise is profound. From creatures once dismissed as insignificant came the architects of the next era. From shrew-like ancestors came elephants and whales, wolves and horses, apes and humans. Mammals remind us that survival is not about being the largest or fiercest in the moment. It is about enduring, adapting, and waiting for opportunity. The asteroid opened the door, but it was mammals who had the courage and capacity to walk through it. When we look at the world today, we see the imprint of this evolutionary triumph everywhere. Herds of ungulates on African plains, pods of whales in the oceans, bats fluttering in twilight skies, primates swinging through forests, all are chapters of the same story. They are the descendants of those who once hid in burrows, who once fed in the shadows of giants, who once endured fire and darkness. The age of mammals began quietly, but it reshaped Earth forever. The rise of mammals was not the end of Earth's story, but it was the beginning of ours. From ash and silence came diversity and dominance. From shrew-like creatures came a lineage that would one day gaze at the stars, tell stories, and ask what it means to be alive. Mammals stepped forward, and in doing so they carried the torch of life into a new age. When the asteroid struck and the cataclysm unfolded, the oceans bore scars as deep as those on land. The seas, once filled with the thunderous presence of mosasaurs and plesiosaurs, fell silent. These great marine reptiles, rulers of the deep for millions of years, vanished alongside the ammonites and many species of plankton that formed the foundation of the marine food chain. Coral reefs collapsed. Vast stretches of water turned murky with debris, and oxygen levels plummeted in many regions. It was not simply the land that endured an apocalypse. The oceans, too, were emptied of their giants. Yet water is life's oldest cradle, and even after devastation, it remained a stage for renewal. With the old masters gone, new predators and new shapes of survival began to emerge. The oceans were reborn. The immediate aftermath was grim. With phytoplankton populations decimated by the loss of sunlight during the long night, everything above them suffered. Zooplankton dwindled, small fish starved, and higher predators followed. Entire ecosystems collapsed from the base up, and for a time the seas were barren. But as the skies cleared and light returned, plankton bloomed once more. This single recovery, tiny organisms floating in the water, sparked the revival of marine life on a global scale. The rebuilding began not with giants, but with the smallest forms of life, invisible to the naked eye, yet powerful enough to rebuild food chains that would eventually produce whales, penguins, and sharks. Among the most successful reclaimers of the oceans were sharks. They had survived the extinction before, and they would do so again. Their evolutionary design, cartilaginous skeletons, replaceable teeth, keen senses, made them resilient in times of collapse. While many marine reptiles vanished forever, sharks endured by feeding on whatever remained: fish, carrion, even smaller sharks. Once ecosystems stabilized, they surged into dominance, evolving into new shapes and sizes. Fossils from the Paleocene and Eocene epochs reveal shark species that grew larger and more diverse, ranging from small reef dwellers to titans like the ancestors of the megalodon. They became the undisputed apex predators of the new seas, filling roles once occupied by mosasaurs. Their legacy continues today, a direct thread from the oceans reborn to the sharks that still prowl our waters. But sharks were not alone in shaping the post-extinction seas. Birds, the very descendants of dinosaurs, claimed an unexpected niche in aquatic realms. Within a few million years, giant penguins appeared in the southern oceans. Fossils from New Zealand and Antarctica reveal species that stood taller than humans, with wings modified into powerful flippers for diving. These penguins were not the tuxedoed birds we know today, but formidable hunters, chasing fish and squid through icy waters with surprising agility. In the absence of marine reptiles, they thrived, filling ecological spaces that had been empty since the extinction. Their bones tell stories of rapid adaptation: denser structures to withstand diving pressure, streamlined forms for speed, and strong beaks for seizing prey. For tens of millions of years, giant penguins reigned as some of the most striking symbols of oceanic rebirth. Even more extraordinary was the entry of mammals into the sea. During the late Paleocene and early Eocene, some land-dwelling mammals began to spend more and more time near rivers, lakes, and coastal waters. At first, they were no more aquatic than an otter, but evolution pushed them deeper. Fossils such as Pachycetus, a wolf-like mammal with traits suited for both land and water, mark the beginning of this transformation. Ambulocetus, the walking whale, followed, a creature that could lumber on land but also propel itself through water with strong limbs. These transitional species paved the way for the full return of mammals to the oceans. By the Middle Eocene, true whales, fully aquatic, streamlined and powerful, had emerged. They were the heirs to an evolutionary gamble, abandoning land to dominate the seas. This transition was monumental. Mammals, once small survivors in the shadow of dinosaurs, had not only conquered land, but returned to reclaim the oceans. Whales became filter feeders, swallowing entire clouds of krill, or evolved into hunters, pursuing fish and other marine mammals with intelligence and coordination. Their rise was not simply a replacement of lost reptiles, but an entirely new approach to oceanic dominance. Warm-blooded, social, and capable of navigating immense distances, whales reshaped the balance of life in the seas. The fact that the largest animal to ever live, the blue whale, arose not among the dinosaurs but in this post-extinction world speaks to the profound rebirth of the oceans. As mammals moved into the seas, pinnipeds, seals, sea lions and walruses followed. These creatures evolved from terrestrial ancestors, developing flippers, streamlined bodies, and insulating blubber. They became versatile predators of coasts and open waters alike. Like whales, their presence is a direct legacy of the extinction event, filling niches vacated by marine reptiles. The oceans had not merely recovered, they had become laboratories for entirely new kinds of life. The seabeds, too, changed. Coral reefs eventually revived, built by new species better adapted to fluctuating climates and nutrient levels. Fish diversified rapidly, producing new forms from tiny reef fish to massive predatory tuna. Cephalopods, such as octopuses and squids, flourished, continuing their ancient role as cunning hunters of the deep. The extinction had cleared the board, but life quickly filled it again with a staggering variety of shapes, behaviors, and strategies. The Paleocene and Eocene seas must have been extraordinary to witness. Imagine standing on a coastline, watching waters teeming with sharks of unfamiliar forms, penguins as tall as men diving like torpedoes, and the first proto-whales splashing awkwardly between worlds. The air would have been filled with seabirds, scavenging along shores rich with fish. It was a theatre of experimentation, of evolutionary daring. The old world of marine reptiles and ammonites was gone, but the new world was no less vibrant. It was in many ways more dynamic, driven by creatures that combined intelligence, adaptability, and endurance. This rebirth also reshaped the planet's climate and ecosystems. Whales, through their immense size and feeding habits, began to influence nutrient cycles, redistributing iron and nitrogen in the oceans. Penguins and seabirds connected marine and terrestrial ecosystems by transporting nutrients from sea to land. Sharks regulated fish populations, preventing imbalances that could collapse ecosystems. Life was not just rebounding. It was weaving new patterns, creating systems more complex than those before the extinction. The story of oceans reborn is a reminder that endings are beginnings in disguise. The loss of mosasaurs, plesiosaurs and ammonites was catastrophic, but it opened ecological doors that would otherwise have remained locked. Sharks surged into dominance, birds reinvented themselves as aquatic hunters, and mammals returned to the seas to begin one of the most remarkable evolutionary experiments in Earth's history. Today, when we watch a whale breach, a penguin dive, or a shark glide through clear waters, we are witnessing the legacy of that transformation. The asteroid did not end life in the oceans, it reset them. The silence of extinction was filled again with movement, song, and struggle. From the smallest plankton to the largest whale, every layer of the marine food chain was rebuilt, not as a copy of what came before, but as a reinvention. The seas, once emptied, became cradles of innovation. The oceans were reborn, and in their renewal, they prepared a stage not only for new predators and prey, but for the future of the planet itself. The world after the asteroid impact was not simply a matter of who lived and who died. It was also a matter of what kind of planet those survivors would inherit. The extinction event had scarred not just the living things, but the very systems that governed air, water, and climate. The skies had been darkened by dust, ash, and sulfur. The land had been burned and frozen in cycles of destruction. Oceans had turned acidic, rivers had run black with soot, and carbon levels had been wrenched violently in different directions. The atmosphere, once steady enough to sustain the lush ecosystems of the Cretaceous, was thrown into chaos. And yet, just as life found ways to recover, so too did the climate. Slowly, unevenly, and sometimes violently, Earth began to find a new rhythm in the Paleocene epoch. In the earliest years after the impact, the Earth's surface was locked in a kind of nuclear winter. Sunlight barely pierced the soot, and global temperatures plummeted. Photosynthesis faltered, winds shifted, and ice crept into regions that had been warm. It was an age of chill and shadow, a time when even tropical zones carried the breath of frost. But the atmosphere did not remain static. As ash and debris finally settled, as sulfur washed out of the skies in acid rains, the curtain began to lift. The sun returned, weak at first but slowly stronger, bringing back warmth to a planet starved of energy. Volcanic activity played a central role in this recovery. The Earth was restless during the late Cretaceous and early Paleocene, with large-scale eruptions continuing in regions such as India's Deccan Traps. These eruptions had already been altering the climate even before the asteroid struck, releasing massive amounts of carbon dioxide and other gases into the atmosphere. After the extinction, they became both a danger and a catalyst for change. On one hand, they injected sulfur and ash that contributed to short-term cooling. On the other, their outpouring of carbon dioxide began to trap heat, nudging Earth toward warming after the initial freeze. The result was not a smooth recovery, but a climate of swings. Cold phases followed hot phases, rainfall patterns shifted dramatically, and sea levels rose and fell. For the survivors, these fluctuations demanded resilience. Plants had to grow in soils still poisoned by acid and heavy metals. Animals had to adapt to ecosystems that changed decade by decade. Yet over the course of hundreds of thousands of years, stability returned. The Paleocene became a time of relative warmth compared to today, with average global temperatures higher and polar regions free of permanent ice. The skies, once clogged with soot, cleared into a more humid and carbon-rich atmosphere. Clouds became engines of rainfall, feeding the spread of forests. With warmth came an expansion of tropical and subtropical zones. Palm trees grew as far north as what is now Wyoming, and crocodiles basked in regions that today see snow. The Earth had tilted into a greenhouse world, a planet of lush greenery and damp air, where jungles sprawled across continents and the poles themselves supported dense vegetation. This greenhouse climate provided fertile ground for the evolutionary experiments of birds and mammals, fueling their expansion into diverse forms. But this new climate came with volatility. Geological records reveal spikes of heat and abrupt cooling events throughout the Paleocene. Some of these may have been triggered by volcanic pulses, while others may have been caused by changes in ocean circulation. The oceans, key regulators of climate, were still recovering from the collapse of plankton populations and chemical imbalances left by the extinction. As plankton returned and began drawing carbon back into the deep sea, global systems slowly recalibrated. The oceans became both reservoirs and movers of heat, carrying warmth from equator to poles, shaping rainfall and redistributing nutrients. The Paleocene also saw the rise of greenhouse gases through natural processes. As forests spread across continents, soils and plants drew down carbon, stabilizing the atmosphere. But volcanic emissions and the decomposition of vast amounts of dead organic matter from the extinction continued to add carbon back. The balance between these processes kept the Earth in a warm state, though not without dramatic pulses. One such pulse, at the very end of the Paleocene, erupted into what scientists call the Paleocene-Eocene thermal maximum, a sudden surge of greenhouse warming that drove temperatures even higher. But in the millions of years before that tipping point, Earth's climate was gradually finding equilibrium after disaster. For the creatures that lived through this recovery, climate was destiny. Mammals, still small but diversifying rapidly, thrived in the warmth. Their metabolisms suited to higher temperatures. Birds expanded in forests that stretched unbroken across latitudes. Reptiles such as crocodiles and turtles, whose lineages had survived the extinction, flourished in the greenhouse climate, extending their ranges farther than ever before. Even insects benefited, diversifying alongside flowering plants in the warm, humid conditions. The atmosphere and the biosphere moved in lockstep, one shaping the other, each recovery feeding the other's resilience. The Earth of the Paleocene must have felt alien to us. Imagine dense tropical forests spreading where temperate regions now lie, with giant ferns and flowering trees shading small mammals and towering birds. Imagine crocodiles and turtles inhabiting waters in regions we now associate with cold. Imagine rainfall not bound to narrow tropical bands, but drenching vast swaths of continents. The rhythms of the seasons would have been less dramatic than today, muted by the greenhouse climate. Winters were mild, summers long and warm. Life thrived in this gentler swing, though it was punctuated by bursts of climate instability. Volcanism continued to shape both landscape and climate. The Deccan Traps released gases for hundreds of thousands of years, altering global temperatures and contributing to warming trends. Mountain-building events shifted atmospheric circulation, changing the way winds and rains moved across continents. Ocean currents, re-establishing themselves after extinction, began to create thermal highways that redistributed energy around the globe. The Earth was not static, it was restless, dynamic, a planet still remaking itself after near collapse. One of the most fascinating aspects of the Paleocene climate was its role in encouraging diversification. In the warmth, plants spread faster, producing new fruits, flowers and seeds. These, in turn, fed birds and mammals, accelerating their evolutionary radiation. New forests created new habitats, from canopy to understory to forest floor, giving mammals chances to climb, leap and forage. Lakes and wetlands expanded under heavy rainfall, fostering amphibians, fish and semi-aquatic mammals. Every pulse of climate brought new challenges but also new opportunities. The oceans reflected this too. Warmer waters allowed for the expansion of species that could not tolerate cold. Coral reefs, though devastated by the extinction, began to rebuild, hosting new fish populations. Marine mammals were beginning their evolutionary journey, testing the waters that had become stable and warm. Sharks diversified, adapting to prey that filled the seas once again. From the viewpoint of climate, the Paleocene seas were nurseries of experimentation, feeding energy into ecosystems that would continue to transform for tens of millions of years. By the middle of the Paleocene, Earth's climate had achieved a new balance, a greenhouse world with warm poles, sprawling forests, and humid air. It was not the climate of the dinosaurs, but it was not barren either. It was a planet renewed, bearing scars but pulsing with vitality. The long night of darkness and cold was over, replaced by a dawn of warmth and abundance. Yet the story of climate recovery is also a warning. The Paleocene showed how fragile balance can be, how easily disrupted by volcanic activity, by carbon spikes, by changes in the oceans. The ecosystems that thrived did so because they adapted to shifts, not because the climate remained steady. Earth's climate is not a static backdrop. It is a living system, intertwined with life itself, constantly moving, adjusting, and reshaping the possibilities of survival. To walk through a Paleocene forest would be to feel the humid breath of a greenhouse Earth, to see mammals scurrying in branches and giant birds striding across clearings, to hear insects buzzing in air, heavy with moisture. To sail its oceans would be to encounter sharks of unfamiliar form, giant penguins diving into shoals of fish, and the earliest mammals beginning their journey back to the sea. All of this was possible because the climate, after near collapse, found a way to mend itself. Ash turned to soil, smoke gave way to clouds, skies once darkened cleared into blue. Volcanoes that belched destruction also seeded renewal. The planet, resilient as its creatures, healed across millennia, reweaving the cycles of carbon, water, and sunlight. The Paleocene was not simply a time after disaster, it was the forging of a new world, a world with a climate that allowed life not just to recover, but to flourish. When the world began to heal after the devastation of the asteroid, life did not simply return to what it had been before. The ecosystems that rose in the Paleocene were not echoes of the Cretaceous, but strange experimental worlds where the survivors tested out new forms, new sizes, and new ways of living. With the dinosaurs gone, ecological space lay open like a stage awaiting new performers. Into that void came an odd parade of creatures, giant snakes coiling through steamy jungles, monstrous birds striding across plains, hoofed mammals with bizarre shapes and teeth unlike anything alive today. The Paleocene was an age of innovation and imagination, when nature seemed to push the boundaries of what was possible. One of the most astonishing creatures of this era was Titanoboa, a snake so large that it defies belief. Reaching lengths of over 40 feet and weighing more than a ton, it slithered through the swamps of what is now Colombia some 60 million years ago. In the hot, humid climate of the Paleocene, where temperatures were warmer than today, reptiles could grow to immense proportions. Titanoboa was not just the largest snake ever known, it was an apex predator, capable of crushing giant fish and even young crocodiles in its coils. Imagine standing in a swamp where such a serpent moved silently through the water, a living remnant of the Cretaceous world, reimagined in monstrous size. Its presence shows that in the Paleocene, nature was willing to gamble with gigantism, especially in the tropics where warmth fueled reptilian growth. But snakes were not the only giants of this time. On land, birds rose to become rulers in the absence of dinosaurs. These were not small songbirds or graceful flyers. They were massive, flightless hunters known as terror birds. In South America, which was isolated from other continents, these predators grew to heights of 3 meters. Their skulls were equipped with huge, hooked beaks, sharp enough to deliver fatal blows. They sprinted across plains on long, powerful legs, hunting small mammals and other creatures. For millions of years, these birds dominated their landscapes as apex predators, filling roles once held by theropod dinosaurs. Their reign is proof that avian dinosaurs did not simply survive the extinction. They reinvented themselves into new forms of dominance. Other bird lineages also experimented with gigantism. In the oceans, penguins grew to human height, diving deep into southern seas to chase fish. Fossils from New Zealand and Antarctica reveal penguins that weighed more than 100 kilograms, their wings transformed into powerful flippers. Unlike their modern descendants, these penguins were titans, exploiting the rich fish populations of warm oceans. They remind us that the Paleocene was not a cautious age of small steps, but a bold age of ecological leaps, where creatures often stretched to extremes. On land, mammals began their great expansion, but their early forms were often bizarre compared to the creatures we know today. Many of them belong to groups that no longer exist, evolutionary experiments that flourished briefly and then faded. Some were hoofed mammals, called condylarths, that ranged in size from fox-like creatures to animals as large as bears. Their teeth were odd, adapted for grinding plants in ways unfamiliar to modern species. Some had long, heavy tails, others moved awkwardly on sprawling legs. They were prototypes of what would later become horses, cattle, and deer, but at this stage they looked alien, as if evolution was sketching ideas in rough drafts. In North America and Eurasia, these early ungulates roamed newly grown forests and meadows. Some grazed on ferns and flowering plants, while others browsed on shrubs. Without large dinosaurs to compete with them, they grew rapidly in size. Within just a few million years of the extinction, mammals had produced forms larger than any that had existed during the Mesozoic. It was as though the evolutionary brakes had been released, allowing body size and diversity to surge forward in ways previously impossible. Alongside these herbivores came predators. In the Paleocene, before the rise of true carnivores like cats and dogs, a group of strange mammals called creodonts took on the role of hunters. With elongated skulls and slicing teeth, they stalked the forests and plains, preying on ungulates and smaller mammals. Though they would eventually be replaced by modern carnivores, creodonts held sway for millions of years, a reminder of how evolutionary dominance can shift from one lineage to another. The Paleocene was also an age of isolation and local experiments. South America, cut off from other continents, evolved its own unique set of mammals, including giant sloths and armadillo-like creatures that would later define its ecosystems. In Europe and North America, forests were filled with early primates, tiny tree-dwelling creatures with grasping hands and forward-facing eyes. In Asia, mammals with tusks and massive bodies began their lineage toward elephants. Each continent became a separate stage where evolution played its own variations, producing an astonishing variety of forms. Amphibians and reptiles, too, experimented with size and form in the Paleocene. Giant turtles the size of small cars swam in rivers and basked on muddy banks. Crocodiles grew large and diverse, taking advantage of warm climates and plentiful prey. Some crocodiles even became semi-terrestrial hunters, chasing animals on land as well as in water. These ancient reptiles thrived in the greenhouse conditions of the Paleocene, a reminder that while dinosaurs had vanished, their reptilian cousins remained strong. The climate itself encouraged these extremes. The Paleocene was warmer than today, with high levels of carbon dioxide and no permanent ice caps at the poles. Tropical forests spread far north and south, creating vast zones of lush, humid habitat. In such conditions, plants flourished, providing abundant food for herbivores. With food came energy, and with energy came the possibility of gigantism. Evolution took full advantage of this opportunity, producing ecosystems that, while unfamiliar to us, were vibrant and full of power. The fossil record of this time reads like a catalogue of imagination. In Colombia's Cerrejón Formation, scientists uncovered remains of Titanoboa alongside giant turtles and crocodiles, painting a picture of swampy jungles teeming with monsters. In South America, the fossils of terror birds tower over those of the mammals they hunted. In New Zealand, the bones of human-sized penguins speak of seas where birds rivaled reptiles in size. In North America and Europe, the teeth of condylarths and creodonts tell of worlds where mammals were trying on new forms, some successful, others doomed to extinction. This age of experimentation was not stable. Many of the Paleocene's strangest creatures would vanish in later epochs as climates shifted and competition increased. Titanoboa disappeared when global temperatures cooled, its immense size no longer sustainable in less tropical conditions. Terror birds would thrive for millions of years, but eventually fall to mammalian carnivores. Creodonts, once dominant hunters, would fade as modern carnivores rose. The condylarths, those odd hoofed mammals, would splinter into the lineages that became today's ungulates. The Paleocene was a time of transition, a crucible in which ideas were tested and only some endured. And yet without this age of strangeness, the world we know would not exist. The Paleocene was the rehearsal for the Eocene, when mammalian giants would stride across continents, when whales would take to the seas, when primates would begin their climb toward intelligence. It was the laboratory where nature experimented with forms both bizarre and brilliant, using the emptiness left by dinosaurs to explore new possibilities. To walk through a Paleocene landscape would be to enter a dream both alien and familiar. Towering birds with raptor-like beaks sprint across open ground. Mammals with strange teeth graze in meadows of flowering plants. A massive snake coils in the undergrowth, its scales glinting in humid air. In rivers, turtles the size of bathtubs drift lazily while crocodiles patrol the banks. The air is heavy with warmth, filled with the buzz of insects and the calls of primitive birds. It is not the world of dinosaurs, but it is not yet the world of humans either. It is a world in between, a place of imagination made flesh. The Paleocene reminds us that life does not rebuild by restoring the past, but by inventing the future. When dinosaurs fell, They left not an empty earth, but an open earth. Mammals, birds, reptiles, and amphibians surged into that openness, trying new strategies, new shapes, new sizes. Some failed, leaving only fossils as their legacy. Others succeeded, becoming the ancestors of the creatures that surround us today. The age of strange beasts was short in geological terms, but it was essential. It was the bridge between catastrophe and the modern world, between extinction and renewal. From titanoboa in the swamps to terror birds on the plains, from giant penguins in the seas to condylarths in the forests, the Paleocene was an age when life dared to be wild, experimental, and strange. It was proof that evolution is not cautious but bold, willing to try everything in the face of loss. And from that boldness came the foundation of the world we know, the mammals, birds, and ecosystems that define our planet today. Forests were the lungs of the Paleocene world, and when they returned after the long night of ash and silence, they did not simply restore what had been lost. They became the scaffolding for a new future, a living architecture that shaped the destiny of mammals, birds, and ultimately humans. With the dinosaurs gone and the climate warmed by greenhouse conditions, flowering plants spread like wildfire, creating dense canopies, shaded understories, and tangled root systems that turned barren landscapes into lush havens. These were the forests of the future, crucibles of diversity, laboratories of adaptation, and homes to creatures who would define the course of evolution for millions of years. In the earlier stages of recovery, ferns had carpeted the land, quick pioneers in the wastelands left by fire. But ferns were a temporary measure. The true architects of the Paleocene were angiosperms, flowering plants. They had already begun their rise in the late Cretaceous, but with dinosaurs gone, they surged into dominance. Their seeds, fruits, and flowers offered new food sources and strategies, changing the very dynamics of ecosystems. By producing fruit to attract animals, these plants created partnerships with birds and mammals who carried seeds far and wide. The forests that emerged were not just passive backdrops, they were engines of interaction, shaping the evolution of every creature that moved beneath their leaves. Imagine walking into one of these early Paleocene forests. The air is humid, heavy with the scent of magnolias, laurels, and figs. Towering, flowering trees stretch overhead, forming a canopy that filters sunlight into golden patterns on the ground. Beneath them, vines coil and ferns spread, while shrubs burst with berries and fruit. Insects hum around blossoms, pollinating tirelessly. Birds dart from branch to branch, scattering seeds in their droppings. Small mammals scurry in the understory, nibbling fruit, digging for roots, or climbing in search of nectar. The forest is alive not just with sound, but with exchange. Plants feeding animals, animals spreading plants, and the whole cycle reinforcing itself. These new forests were critical for mammals. For millions of years, mammals had survived in the shadows, small and mostly nocturnal, feeding on insects or hiding underground. The rise of flowering forests offered them fresh opportunities. Arboreal habitats favored those with grasping limbs and flexible bodies. In these conditions, the first primates began to emerge. Small, squirrel-sized mammals developed forward-facing eyes for depth perception, hands and feet that could grip branches, and a reliance on fruit and leaves. They were not yet monkeys or apes, but they were the ancestors of both. In the branches of Paleocene forests, the groundwork for human evolution was being laid. For other mammals, the forests provided new diets and niches. Herbivorous ungulates browsed on leaves and shoots, evolving teeth suited for chewing fibrous plant matter. Omnivores thrived on the fruits and seeds, using their varied diets to adapt to shifting climates. Predatory mammals, creodonts at this stage, learned to stalk through dense undergrowth, their teeth sharpening into tools for slicing flesh. The forests created complexity, and complexity bred diversity. Within a few million years, mammalian species had multiplied, each adapting to its corner of the ecosystem. Birds, too, flourished in these forests. Some species specialized in eating seeds, their beaks evolving into powerful crushers. Others adapted for nectar, inserting slender beaks into blossoms. Still others became predators, swooping down on small mammals or reptiles in the dappled light of the canopy. The forests gave birds opportunities to expand far beyond their Cretaceous ancestors. Their songs filled the humid air, communication tools honed in the acoustics of thick vegetation. The forests were not just habitats for birds, they were stages where avian evolution composed its first symphonies. Insects became perhaps the greatest beneficiaries of these forests. Flowering plants had evolved to lure them, and insects responded with extraordinary adaptations. Bees, butterflies, and beetles diversified rapidly, refining their relationships with blossoms. The buzzing of insects was the pulse of these new ecosystems, ensuring that pollen moved from flower to flower, that seeds grew, and that forests could expand. With every wingbeat, they shaped the biosphere, creating a feedback loop of abundance. The forests also altered Earth itself. With their dense vegetation, they pulled carbon dioxide from the air, moderating the greenhouse atmosphere and storing it in roots and soil. They stabilized climates locally, creating moist, shaded microenvironments where delicate creatures could survive. They influenced rainfall patterns, drawing water from the air and returning it as mist and rain. These forests were not only cradles of life, but also regulators of the climate, helping Earth steady itself after the chaos of extinction. Fossil evidence reveals the richness of these forests. Leaf imprints from the Paleocene show broad, glossy leaves of tropical species in places that today are temperate. Fossilized pollen records the rise of oaks, walnuts, and palms. The bones of early primates, with fingers adapted for grasping, are found alongside teeth of mammals that gnawed fruit. Even coprolites, fossilized droppings, show seeds and plant fragments, evidence of the partnerships that bound animals and plants together. The forests of the future were not imagined, they are written in stone. But these forests were not static paradises, they were dynamic, ever-changing arenas. As climates shifted during the Paleocene, forests expanded and contracted, pushing species to migrate, adapt, or perish. Floods and droughts reshaped landscapes. Volcanic eruptions periodically disrupted growth, blanketing forests in ash before renewal began again. The Paleocene was not a gentle age, but its forests were resilient. They always returned, weaving life back into burned or flooded land. Predators and prey played out their dramas in these forests. Terror birds sometimes stalked the edges, waiting for mammals to stray from the safety of trees. Snakes coiled among branches, ready to strike. Mammals grew cleverer, more agile and more social, learning to survive in the intricate webs of competition. Every rustle of leaves, every call of a bird, every snap of a twig was part of the constant tension between survival and death. Yet from this crucible of challenge came innovation. New senses, new strategies, new intelligence. By the end of the Paleocene, these forests had reshaped the planet. They were global, stretching into latitudes that today see snow, creating corridors of life across continents. They prepared the way for the Eocene, when mammals would explode into even greater diversity, when primates would become more complex, when whales would emerge from land-dwelling ancestors. The forests of the Paleocene were both a refuge after extinction and a launchpad into the next great chapter of evolution. The forests we walk in today, whether temperate woodlands, tropical rainforests, or urban parks, carry the echoes of these ancient systems. Every oak, every palm, every flowering tree is a descendant of the survivors that rebuilt Earth's green mantle after the extinction. Every bird that eats a berry, every primate that climbs a branch, every insect that pollinates a flower is part of a story that began in those shadowy, humid forests millions of years ago. The Paleocene forests were not just ecosystems, they were turning points. They transformed ash into abundance, silence into song, extinction into renewal. They were the canvas upon which evolution painted the next era of life, offering niches, shelter, and food to species bold enough to take them. And in their branches, in their fruits, in their roots, they sowed the seeds of futures yet to come, futures that would include us. The Paleocene forests, jungles, and wetlands did not remain havens of quiet herbivores and seed-eaters for long. Where there are grazers, there will always be hunters, and as the ecosystems grew more complex, predators began to carve their place once more. The dinosaurs were gone, their teeth and claws lost to the ash of extinction, but the balance of life required a new generation of hunters to rise. The story of the Paleocene is not only one of plant growth and mammalian expansion, but also of predatory power returning in strange and often terrifying forms. This was the chapter when predators reclaimed the earth, when mammals sharpened their teeth, birds turned into hunters, and ecosystems found their rhythm in the ancient dance of chase and escape. In the earliest years after the extinction, the world was strangely quiet in predatory terms. The great theropods were gone, and nothing immediately replaced them. Mammals, still small, mostly scavenged or ate insects and seeds. Crocodiles and snakes were perhaps the most dangerous carnivores of the time, lurking in rivers or undergrowth. But as forests thickened and herbivores grew larger, opportunities opened. Nature abhors imbalance, and soon predators evolved to exploit the rising abundance. By the middle of the Paleocene, new hunters were spreading across continents. The first mammalian predators to claim dominance were the creodonts. This now extinct order of carnivorous mammals appeared early in the Paleocene and ruled as apex predators for nearly 30 million years. They looked somewhat like wolves or hyenas, but were neither. Their skulls were long, their jaws powerful, and their teeth shaped for slicing meat. Fossils show them ranging from small, fox-like hunters to massive beasts capable of bringing down ungulates. Some were forest stalkers, others plain sprinters, but all carried the same role, restoring the top of the food chain. For the herbivores of the Paleocene, the rise of the creodonts meant constant vigilance, every rustle in the underbrush a potential death sentence. But creodonts were not the only predators of this age. Birds, descendants of dinosaurs, stepped boldly into roles left empty by their reptilian cousins. In South America, isolation gave rise to the Forus racids, terror birds, towering over most mammals, some reaching 3 meters in height. They were apex hunters, unlike anything alive today. Their massive beaks, hooked and sharp, could crack bone and tear flesh. Their long legs propelled them at speeds fast enough to chase down prey across open ground. Imagine a bird taller than a man, with the hunting power of a big cat, patrolling grasslands and forests. For millions of years, terror birds reigned unchallenged as the kings and queens of predation. In the oceans, sharks surged into dominance. Freed from competition with marine reptiles, they diversified rapidly. Some species grew to enormous sizes, hunting fish, birds, and even early marine mammals. The seas became theatres of pursuit and ambush once more, as sleek predators honed their senses to detect the faintest vibration or drop of blood. Giant penguins and early whales would have faced sharks as both competition and threat, ensuring that the reborn oceans were never free from fear. Snakes, too, reached terrifying extremes. Titanoboa, the giant serpent of Paleocene South America, was more than 40 feet long and a ton in weight. Its coils could crush crocodiles, its ambushes deadly in steamy swamps. While it did not dominate globally, its very existence reveals how predators seized every possible niche. Where climate allowed, reptiles continued to rival mammals and birds, creating local kingdoms of terror. Crocodiles thrived as well. Survivors of the extinction, they expanded in both size and diversity. Some became semi-terrestrial, hunting not only in water but also on land. Others specialized in rivers and lakes, ambushing unwary mammals that came to drink. With their patience, armored bodies and bone-crushing jaws, they remained formidable reminders that reptiles were far from finished. In many ecosystems, crocodiles were as dangerous as any mammalian predator. This renewal of predation was not simply a matter of replacing what had been lost. It reshaped the survivors in profound ways. Herbivorous mammals evolved better defenses, sharper senses, swifter legs, tougher hides. Birds took to trees in greater numbers, nesting in high branches to avoid ground-based predators. Social behaviors grew more important, as herds and flocks provided safety in numbers. Intelligence became a survival tool, allowing prey to anticipate threats and predators to outwit their quarry. In this way, the rise of predators drove the rise of complexity across ecosystems. The Paleocene predator-prey balance was unlike anything before. Dinosaurs had produced giants locked in constant battles, tyrannosaurs against ceratopsians, raptors against hadrosaurs. In contrast, the Paleocene offered diversity rather than uniformity. Predators came in many shapes: birds with talons, mammals with slicing teeth, reptiles with coils or jaws. Their prey was equally varied, from squirrel-sized mammals to early ungulates. This variety produced dynamic, shifting ecosystems where no single predator dominated everywhere. It was an age of balance forged through experimentation. One of the most fascinating aspects of Paleocene predation is how it foreshadowed the world to come. Creodonts, though successful, were evolutionary placeholders. By the late Eocene, they would decline, replaced by true carnivorans, the ancestors of cats, dogs, and bears. Terror birds, though terrifying, would eventually fall as mammalian carnivores spread into South America during the Great American Interchange millions of years later. Titanoboa would vanish as climates cooled, and crocodiles would retreat to narrower ranges. The Paleocene predators were both rulers and transitional figures, shaping ecosystems while paving the way for their successors. Yet for the creatures that lived in those forests and wetlands, these predators were not experiments. They were reality. A small mammal scurrying through the undergrowth had to fear the silent swoop of a bird or the sudden snap of a snake. A young ungulate grazing in a clearing risked ambush by a creodont lurking in shadows. Life was tense, precarious, and dangerous, but it was also fertile ground for adaptation. Every chase and every escape honed survival skills that would echo through evolution. If one could stand in a Paleocene forest at dawn, the scene would be far from peaceful. The mist would rise among flowering trees, dew dripping from broad leaves, while flocks of primitive birds called to one another. In the distance, a herd of hoofed mammals would graze nervously, ears twitching at every sound. Suddenly, the silence would break. A terror bird sprinting from the trees, its beak open in a silent scream, scattering prey in all directions. Elsewhere, by a riverbank, a crocodile would lunge upward, seizing an unwary mammal in its jaws before vanishing into the water. In a swamp, the shadow of Titanoboa would ripple beneath the surface, waiting for its next victim. This was not a world of gentle renewal. It was a world where predators had returned to test the mettle of survivors. The importance of predators cannot be overstated. By keeping populations in check, they prevented ecosystems from collapsing under the weight of overgrazing. By selecting the weak and the unwary, they drove prey species to grow stronger, faster, and smarter. They restored the equilibrium of life, ensuring that abundance was balanced by challenge. Without predators, the Paleocene forests might have become stagnant, their food chains imbalanced. With predators, they thrived in cycles of growth and culling, abundance and scarcity. The return of predators in the Paleocene was the final step in Earth's ecological recovery. It marked the point when ecosystems once again had full complexity. Plants, herbivores, omnivores, and carnivores, all bound together in a web of survival. It was the moment when the world stopped being a scarred remnant of catastrophe and became a living, breathing system once more. It was also the stage setter for everything that came after: the rise of true carnivores, the dominance of mammalian megafauna, and eventually the appearance of humans, predators of a different kind. Predators came back in forms that astonished, horrified, and sometimes bewildered. They were not dinosaurs, but they were no less fearsome. They were experiments in efficiency and brutality, teachers of adaptation and guardians of balance. In their presence, the Paleocene world was not merely reborn, it was tested, sharpened, and prepared for the ages to come. In the dappled light of Paleocene forests, while giant snakes slithered in swamps and terror birds stalked the ground, another story was unfolding high in the canopy. It was quieter, less dramatic than Titanoboa's ambushes or Creodonts' hunts. But it would one day prove more consequential than any of them. Small mammals, no larger than squirrels, were beginning to explore a new way of life among the branches. Their hands grew better at gripping. Their eyes shifted forward, trading panoramic vision for depth perception. Their brains swelled slightly, adapting to the complexity of three-dimensional movement in the trees. These were the earliest primates, timid, delicate creatures who lived in the margins of the Paleocene, but who carried the seeds of a future that would reshape the Earth. The forests of this epoch were thick and sprawling, filled with flowering plants, fruits, and insects. They offered both refuge and opportunity. For small mammals, the canopy provided safety from many predators, though snakes and birds of prey still lurked. More importantly, it offered food. Flowers and fruits, a new abundance in the post-dinosaur world, gave mammals a reason to leave the ground. The ancestors of primates took advantage of this bounty, evolving bodies suited to climbing, leaping, and foraging. Their fingers lengthened, their nails flattened, and their sense of touch became more refined. These subtle shifts were revolutionary, turning them into creatures capable of grasping not only branches, but eventually ideas. One of the earliest known primate-like mammals was Purgatorius, a small insect and fruit eater that lived in North America soon after the extinction. Its teeth suggest a diet of both insects and plant matter, a flexible strategy well suited to changing ecosystems. Though tiny and unassuming, Purgatorius and its relatives represent the first steps toward a lineage that would eventually include monkeys, apes, and humans. In their simple adaptations lay the beginnings of intelligence, social behavior, and tool use. The Paleocene canopy was their classroom, teaching them coordination, problem-solving, and survival in a complex environment. The evolution of primates was deeply tied to the rise of flowering plants. Angiosperms produced not only fruit, but also nectar and seeds, attracting insects in great numbers. This created a food web ripe for exploitation. Early primates fed on fruit for energy, insects for protein, and leaves for survival when resources grew scarce. In turn, they became important seed dispersers, carrying plant offspring in their stomachs and scattering them across forests. It was a mutually beneficial partnership. Plants fed the primates, and primates spread the plants. The bond between primates and forests, first forged in the Paleocene, would remain unbroken to this day. Their forward-facing eyes were another crucial adaptation. Many mammals of the time had eyes on the sides of their heads, useful for spotting predators but poor for judging distance. In the trees, however, depth perception was essential. A misjudged leap could mean death. Natural selection favored those whose vision overlapped, allowing them to see in 3 dimensions. This shift towards stereoscopic vision was a small change in anatomy, but a monumental one in destiny. It prepared primates for a world where intelligence, hand-eye coordination, and social complexity would become survival strategies as important as teeth and claws. Social behavior may also have taken root in these early primates. Living in trees meant living close together, with overlapping territories and constant competition for fruiting trees. Cooperation, whether in grooming, warning calls, or group foraging, offered survival advantages. The seeds of social bonds, of living not as solitary creatures but in small groups, were likely planted here. Over millions of years, those bonds would evolve into the intricate societies of monkeys and apes, and eventually into human culture. The Paleocene world was still dominated by odd-hoofed mammals, creodont predators, and reptilian giants, but the primates were writing a different story. They were not aiming for size or strength. Their power lay in subtlety, in touch, sight, flexibility, and brain power. These traits did not make them apex predators in their day, but they set them on a trajectory toward long-term success. Evolution was gambling, and in primates, it gambled on intelligence. Fossil evidence from the Paleocene and early Eocene reveals these small creatures scattered across continents. Their teeth, delicate and suited for fruit, mark them as distinct from insectivores. Their fingerbones show grasping ability, and their skulls hint at expanding vision. In some regions, like Asia and North America, early primates flourished in forests that stretched into high latitudes. Their global distribution suggests that they were remarkably adaptable, able to thrive in diverse climates as long as forests were present. In the shadow of larger animals, primates remained minor players for millions of years. Terror birds and creodonts ruled as predators, ungulates as grazers, and reptiles as ambushers. Yet the small primates persisted, weaving themselves into the canopy, perfecting their skills in ways unnoticed by the giants below. They were never dominant in the Paleocene, but they were never erased either. Survival was their victory, patience their weapon. The significance of their rise becomes clearer in hindsight. From these tiny forest dwellers would come the lemurs of Madagascar, the monkeys of Africa and Asia, the apes of the Miocene, and eventually Homo sapiens. The grasping hands that first clutched Paleocene branches would one day paint cave walls, build cities, and launch spacecraft. The forward-facing eyes that judged leaps in a humid canopy would one day peer through telescopes at galaxies. The social grooming of tiny groups would one day evolve into language, culture, and history. The Paleocene primates did not know it, but they were the foundation of a lineage that would come to dominate the planet in ways more profound than dinosaurs ever had. Their story also reflects the importance of the environment. Without the forests of the Paleocene dense with fruit and flowers, primates might never have evolved their defining traits. The climate, warm and wet, created the conditions for arboreal life. The extinction, by clearing dinosaurs from the stage, created the opportunity. The plants and trees offered the resources. Evolution provided the adaptations. Together, these forces shaped the earliest primates into something new, something with possibilities that would echo far into the future. To stand in a Paleocene forest and glimpse these small creatures would not inspire fear as Titanoboa might, nor awe as terror birds did. Instead, it would inspire curiosity. A small animal with bright eyes, grasping fingers, and a surprising awareness of its surroundings, moving from branch to branch with agility and intent. You might not guess it, but you would be looking at the future of Earth's intelligence. You would be looking at the first step toward us. The Paleocene was an age of experiments, snakes that grew to monstrous lengths, birds that became land-stalking killers, mammals that reinvented body forms. Among those experiments, primates were quiet and unimposing. Yet their adaptations, hands, eyes, brains, were more enduring than any giant's bulk or predator's bite. They were not simply surviving, they were preparing. Preparing for an age when size would matter less than thought, when claws would matter less than cooperation, when the ability to imagine would change the course of the world. The rise of primates in the Paleocene was not a triumph of domination, but of persistence. It was a reminder that evolution rewards not only strength and speed, but also subtlety and potential. From these unassuming creatures, history would one day unfold in ways that even Titanoboa or the terror birds could never match. The earth of the Paleocene was warm, humid, and forested, but nothing in geology stays still. Beneath the quiet canopy of flowering trees and the hum of insects, the planet itself was moving. The continents that once formed the supercontinent Pangaea were still drifting apart, carried slowly by the restless churn of tectonic plates. Volcanoes rumbled, mountains rose, seas advanced and retreated, and climates shifted in ways that would test every creature that had begun to flourish in the post-dinosaur world. The Paleocene gave mammals and birds their chance, but the story of their success could not be separated from the deep forces of ice and fire that sculpted the earth beneath their feet. In the early Paleocene, global temperatures were higher than today, and there were no permanent ice caps at the poles. Tropical forests stretched across latitudes that now lie under snow. Yet even as the world basked in this greenhouse state, the seeds of future climate shifts were being planted by tectonic restlessness. Continents were not fixed. They moved like rafts on a molten sea, colliding, rifting, and reshaping oceans. These movements changed wind patterns, altered rainfall, and opened or closed migration routes for plants and animals. Evolution in the Paleocene was as much about responding to shifting land as to competition between species. One of the most dramatic forces at work was volcanism. The Deccan Traps in India had erupted massively at the end of the Cretaceous, contributing to the extinction itself. In the Paleocene, volcanic activity continued elsewhere, releasing gases into the atmosphere and reshaping local climates. Volcanoes were paradoxes, destructive in the moment, but long-term agents of renewal, creating fresh soils rich in minerals that fed forests. For mammals scurrying through the undergrowth, these eruptions were catastrophes. For plants, they were new beginnings. For evolution, they were accelerators, disrupting stability and forcing species to adapt quickly or die. Meanwhile, mountains were rising. As the Indian subcontinent drifted northward, it approached Asia, setting the stage for the colossal uplift of the Himalayas. Though the full collision would come later, the first pressures of that meeting were already changing the land. Elsewhere, ranges were forming and eroding, reshaping drainage patterns and creating new rivers. Each mountain born meant rain shadows and deserts on one side, lush valleys on the other. Creatures that lived in these regions faced choices: move, adapt, or vanish. Over time, these geological upheavals sculpted the habitats that mammals and primates would learn to navigate. The oceans, too, were in flux. The Atlantic widened as North America and Eurasia drifted apart. South America remained isolated, a land of its own evolutionary experiments. Australia began its long drift away from Antarctica, carrying its unique marsupial mammals with it. The isolation of continents fostered diversity, creating ecosystems where species evolved without interference from outside competition. But isolation also meant vulnerability. When climates shifted or predators arose, entire lineages could vanish in a single region. Earth was becoming a patchwork of evolutionary laboratories, each shaped by the slow grind of tectonics. Climate in the Paleocene was not stable. Though greenhouse warmth dominated, fluctuations were frequent. Fossil evidence shows intervals of cooling and drying, likely triggered by shifts in ocean currents or volcanic pulses. A species that thrived in one phase might collapse in the next. These swings favored adaptability. Mammals with flexible diets, birds that could migrate, and plants with seeds able to wait out harsh years had the advantage. Evolution rewarded those who could ride the waves of instability rather than those fixed to narrow niches. The interplay of fire and ice, volcanic heat and creeping cool periods shaped the story of life. Warmth expanded forests into higher latitudes, while cooler intervals contracted them, opening grasslands and shrublands. Early ungulates, the hoofed mammals, evolved bodies suited for running across open ground as well as browsing in woodlands. Predators adapted in turn, learning to hunt in both dense cover and open plains. Primates clung to forests, but even they had to cope with changes in fruiting patterns and canopy cover. Every climate shift was a test, and every survivor bore the mark of those trials in their anatomy. One of the most telling consequences of these changes was the gradual preparation for the Great Paleocene-Eocene Thermal Maximum, PETM, a dramatic spike in global temperatures around 56 million years ago. During the Paleocene itself, carbon dioxide levels were already high, driven by volcanism and the slow release of carbon from soils and oceans. Forests thrived in this warmth, but the system was precarious. When additional carbon later surged into the atmosphere, whether from volcanic activity, methane release, or both, the planet would tip into a feverish greenhouse state. The Paleocene was a calm before that storm, a time when ecosystems stabilized just enough to set the stage for explosive change. The creatures of the Paleocene were not aware of these planetary shifts, but they felt them. A herd of condylarths in North America might find its meadow shrinking as forests advanced during a warm interval. A terror bird in South America might lose prey as drought withered rivers. A primate in Asia might adapt to new fruiting patterns as rainfall changed with monsoon shifts. These pressures honed resilience. They ensured that by the end of the Paleocene, life was not fragile, but prepared, flexible, and poised for the challenges of the Eocene. Geology and biology were intertwined. Mountains created rivers that shaped forests. Volcanoes fertilized soils that fed plants. Oceans carried warmth that nurtured penguins and early whales. In turn, plants drew carbon from the air, shaping climates. Animals dispersed seeds that expanded forests. Predators kept herbivores in check, preventing overgrazing that could destabilize ecosystems. The Earth was a single, interconnected system, and in the Paleocene it was recalibrating itself, balancing between fire and ice, chaos and renewal. If one could stand on a Paleocene landscape and watch not just for a day, but for a millennium, the changes would be striking. Forests advancing and retreating with climate shifts. Rivers carving new valleys as mountains rose. Volcanoes blackening skies before forests returned to blanket the cooled lava. Oceans creeping inland or retreating, exposing new coastlines. Life would be forced to move, to shift ranges, to experiment with new ways of being. This was not a static planet, but a restless one, teaching its survivors to be restless too. In hindsight, this restlessness was a gift. It meant no lineage could become too complacent. It forced mammals, birds, and reptiles to adapt constantly, honing traits that would ensure their success in future ages. It prepared primates to navigate complexity, ungulates to master open ground, whales to return to the seas. The Paleocene was not a stable Eden, but a forge, its hammer blows of ice and fire shaping the steel of evolution. The age of mammals was only beginning, but it was built on the shifting foundations of Earth itself. The giants of the future, elephants, whales, humans, would owe their existence not only to survival after the asteroid, but also to the restless geology of the Paleocene. The continents drifted, the mountains rose, the volcanoes breathed fire, and through it all, life adapted. The world was alive, not only with creatures but with the very ground beneath them. On warm Paleocene coastlines, where rivers met shallow seas and forests leaned over tidal flats, some land mammals began an extraordinary experiment. They were not giant predators or mighty herbivores, not the terror birds or titanoboas that dominated headlines of survival. They were small, hoofed creatures, curious and opportunistic, drawn to the edges of the water in search of food. At first, they waded in for fish, for shellfish, for whatever resources the shore could offer. But over generations, their limbs, lungs, and senses began to change. What began as tentative splashing at the water's edge turned into one of the most dramatic evolutionary transformations in Earth's history. These were the ancestors of whales, mammals, who abandoned land to become the masters of the oceans. The idea that whales, blue whales, humpbacks, orcas, descended from land-dwelling mammals sounds impossible, yet fossils from the Paleocene and Eocene tell this very story. At first, there were creatures like Pachycetus, a wolf-like mammal with hooves and sharp teeth living around 50 million years ago. Its fossils suggest it hunted along riverbanks, dipping into water for fish, but still moving on land with ease. Pachycetus was not yet a whale, but it was the first spark of that lineage. Its body carried hints of aquatic life, the early whispers of an adaptation that would soon accelerate. Following Pachycetus came Ambulocetus, the walking whale. Imagine a crocodile with mammalian features, long, powerful limbs that could paddle through water but still support it awkwardly on land. Ambulocetus swam by undulating its spine, a movement still seen in modern whales and dolphins. It hunted like a crocodile, ambushing prey in shallow water, but its bones tell us it was already leaning heavily into aquatic life. Its nostrils had begun to shift farther back on its head, an early step toward the blowholes of whales. Its body was elongated, its tail strong, preparing for a future where legs would give way to flippers. Over the next few million years, this transformation accelerated. Mammals like Rhodhocetus and Protocetus show further changes. Hind limbs shrinking, tails becoming more powerful for propulsion, and bodies elongating for streamlined swimming. Their ears adapted to hear underwater, a crucial shift for hunting and communication. Their skeletons grew denser, helping them dive, while their nostrils continued their migration toward the top of the skull. Each fossil is like a frame in a time lapse, showing step by step how a land mammal became a sea giant. Why did mammals make this leap? Part of the answer lies in opportunity. After the extinction of marine reptiles, the oceans were open ecological theatres, rich in fish, squid, and other prey. Sharks ruled, but there was room for innovation. Mammals, warm-blooded and adaptable, could exploit niches reptiles had left behind. Once a lineage began moving into water, natural selection rewarded every advantage. Stronger tails for swimming, streamlined bodies for speed, echolocation for hunting in murky depths. What began as a shoreline habit became a full commitment to aquatic life. By the late Eocene, true whales had arrived, fully aquatic, incapable of returning to land and specialized for life in the oceans. Some, like Basilosaurus, stretched over 50 feet long, with serpentine bodies that glided effortlessly through seas. Its tiny, useless hind limbs were relics of its land ancestry, reminders that it had once walked. Others became early filter feeders, laying the groundwork for baleen whales that would one day strain krill by the ton. The transformation was complete. Mammals had reinvented themselves as ocean titans, their songs and migrations replacing the silence left by mosasaurs and plesiosaurs. This evolutionary journey was not just about anatomy, but about strategy. Whales became social, hunting in pods, caring for their young, and communicating with sound across vast distances. Their intelligence grew, shaped by the demands of navigating oceans and coordinating hunts. From the start, their success was tied not only to bodies built for water, but to minds capable of complex behavior. The seeds of dolphin playfulness and whale song were planted in this Paleocene and Eocene transition. The rise of whales also reshaped oceans. As predators, they influenced fish populations. As filter feeders, they regulated plankton and krill. Their movements circulated nutrients, fertilizing ecosystems. Even their carcasses, when they sank to the seafloor, became entire habitats, whale falls, that sustained deep-sea communities for decades. The oceans were not just a backdrop for whales. Whales became architects of oceanic life. The transformation from shore to sea remains one of the most extraordinary in evolutionary history. Fossils tell us it happened step by step, yet the leap still feels astonishing. How does a creature with hooves become a creature with flippers? How does a wolf-like hunter become a singer of the deep? The answer lies in the Paleocene and Eocene, in the restless creativity of life after extinction. When ecological space opened, mammals were bold enough to fill it, even if it meant abandoning land altogether. To imagine this world is to picture coastlines alive with experiments. Herds of ungulates graze inland, while at the shore, smaller relatives wade into shallows. A predator resembling a mammalian crocodile lunges into water, dragging prey beneath the surface. Farther out, sleek swimmers test new methods of propulsion, half at home in water, half trapped by their land-borne bodies. Above them, penguins dive, sharks circle, and giant birds hunt fish. It is a scene of transition, of creatures caught between worlds, of life writing new rules for itself. The story of whales is also a reminder of evolution's boldness. It does not hesitate to redraw the boundaries of possibility. Land mammals became sea giants. Creatures of breath became masters of depth. In their bones, whales still carry the memory of that journey. Their flippers bear the skeletal pattern of a mammalian hand. Their spines undulate like those of their early amphibious ancestors. Their vestigial hips, hidden within flesh, whisper of legs long lost. They are monuments to transformation, living testaments to the Paleocene's spirit of reinvention. And for humans, there is a peculiar resonance. Our own ancestors were also small Paleocene mammals, clinging to survival in forests. While some of our kin learned to climb trees, others learned to swim oceans. Both paths came from the same root of adaptation, from the same moment when the dinosaurs fell and mammals seized the earth. The whales are our cousins in destiny, their song an echo of a choice made millions of years ago at the shoreline. The Paleocene and Eocene seas became theatres not only of predators like sharks, but of pioneers like whales. From the shorelines of a warming world came creatures who would dominate oceans for millions of years, growing larger than any animal before or since. The land lost them, but the seas gained their kings. And as their voices still ripple through salt water today, they remind us that the extinction that ended the dinosaurs was not only a story of death, but of bold new beginnings. The Paleocene had been an age of recovery and experimentation, but by the time the Eocene arrived, life on land was ready to make bolder statements. The stage left empty by dinosaurs was vast, and mammals, once confined to the shadows, were now free to expand in size, shape, and ecological role. What emerged over the next tens of millions of years was a parade of giants, elephants, rhinos, ground sloths, and other immense mammals that reclaimed the terrestrial world in forms as awe-inspiring as the dinosaurs they followed. They were not reptiles with scales and claws, but warm-blooded, furred creatures, carrying young in wombs instead of eggs, and shaping the earth in ways that would echo down to the present day. The path to gigantism began with opportunity. With forests spreading and climates warm, food was abundant. Fruits, leaves, and grasses offered rich resources for any creature large enough to reach or graze them. Size was an advantage, protecting against predators and granting access to resources smaller creatures could not reach. Over time, natural selection favored mammals that grew larger, stronger, and more specialized. What began as hoofed condylarths in the Paleocene evolved into a dizzying array of ungulates in the Eocene and Oligocene, animals that would lay the foundation for elephants, horses, camels, and antelopes. Among the most extraordinary of these were the early proboscideans, the ancestors of elephants. In the late Paleocene and early Eocene, creatures like Merotherium roamed wetlands in Africa. They were small compared to modern elephants, pig-sized, semi-aquatic with short trunks, but they represented the beginning of a lineage that would one day produce mammoths and mastodons. Their teeth adapted for grinding plants, their bodies grew heavier, and their trunks became longer and more versatile. Over millions of years, proboscideans grew in size until they became the massive architects of savanna and forest we know today. They not only consumed vast quantities of vegetation, but also reshaped landscapes, knocking down trees, creating grasslands, and redistributing seeds in their dung. In Asia, another group of giants arose, the Indricotheres, relatives of rhinos. These animals, which flourished later in the Oligocene, were the largest land mammals ever known. Standing over 16 feet at the shoulder and stretching more than 25 feet in length, they weighed as much as small dinosaurs. Yet they were herbivores, peacefully stripping leaves from tall trees with their long necks. Their size alone deterred predators, and their bulk reshaped ecosystems, consuming tons of vegetation and shaping plant communities. In them, we see mammals reclaiming the ecological space once held by sauropod dinosaurs, giants who ruled by sheer immensity. In South America, isolated from other continents, evolution wrote its own script. Giant ground sloths appeared, some reaching the size of elephants. Unlike their tree-dwelling cousins of today, these sloths were terrestrial powerhouses, slow-moving but nearly unassailable in size. They grazed and browsed, using massive claws to pull down branches. Later, when humans eventually arrived, these sloths would inspire myths of monsters and beasts too large to be real. In their Paleocene and later descendants, we glimpse the creativity of evolution when continents are left to experiment in isolation. Other mammals also experimented with size. Brontotheres, relatives of horses, grew massive, with knobby skulls and heavy bodies, roaming North America and Asia in herds. Giant tapir-like creatures evolved in lush forests. Even carnivores began to grow larger to match their prey. Creodonts and later carnivorans increased in size, hunting ungulates in packs or ambushing them in forests. The arms race of size and survival, herbivore versus predator, reshaped entire continents. But gigantism was not only about power, it was about resilience. Larger bodies could store energy, survive seasonal scarcity, and travel greater distances. They could fend off predators and dominate watering holes. Size came with costs, longer gestation, slower reproduction. But in stable climates, those costs were balanced by survival advantages. The Eocene greenhouse world, with its forests and wetlands, was fertile ground for the rise of giants. The Earth itself encouraged this transformation. With continents drifting, climates shifting, and new mountain ranges forming, environments became diverse. Grasslands began to appear in patches, rewarding grazers with strong teeth and large stomachs. Forests remained lush in many regions, fostering browsers capable of reaching high branches. Wherever resources concentrated, large mammals emerged to exploit them. The Paleocene had been the rehearsal. The Eocene and beyond became the main performance of mammalian gigantism. Walking through such a world would have been breathtaking. Imagine herds of massive Brontotheres moving across plains, their skulls adorned with horn-like knobs. Picture giant ground sloths pulling down branches with claws the length of swords. Hear the trumpeting calls of early proboscideans echoing across wetlands. Predators, though dangerous, seemed small in comparison to their prey, darting and lunging at giants whose bulk alone could crush them. This was a planet not of dinosaurs, but of mammals who had learned to play the same game of size and survival. Yet, gigantism was always fragile. When climates shifted too rapidly, or when food supplies dwindled, giants suffered first. Their size made them powerful but also inflexible. Many of the largest mammals of the Paleocene and Eocene would vanish in later epochs, replaced by new giants better suited to the conditions. Indricotheres disappeared as climates cooled and forests retreated. Brontotheres fell to extinction when their specialized diets failed. Even ground sloths would one day succumb, both to climate changes and to human hunters. Gigantism was a strategy, but never a guarantee. Still, the story of these giants is one of triumph. From shrew-sized survivors of the asteroid, mammals had grown into beasts that rivaled dinosaurs in size and ecological importance. They reclaimed the Earth, not with scales and claws, but with fur, milk, and intelligence. They reshaped landscapes as profoundly as dinosaurs had, leaving behind fossil beds that remind us of their grandeur. In them, the age of mammals fully came into its own. The giants of the Paleocene, Eocene, and beyond remind us of nature's cycles. Extinction clears the stage, and new players rise to fill the roles. Where once sauropods grazed treetops, indricotheres later browsed. Where once tyrannosaurs stalked herds, creodonts and big cats prowled. The cast changes, but the play continues, life forever reinventing itself to match the conditions of Earth. To stand among these giants would be to feel the same awe once inspired by dinosaurs. A world alive with immensity, where survival was written not only in teeth and speed, but in sheer size. The Paleocene had opened the door. The Eocene had filled it with titans. The age of mammals was no longer a story of small survivors. It was a story of giants reimagined. In South America during the Paleocene and Eocene, while mammals were tentatively experimenting with size and shape, another lineage seized the opportunity left by the extinction of the dinosaurs. They were not reptiles nor mammals, but birds, descendants of theropod dinosaurs, survivors who had learned to endure the darkness and scarcity after the asteroid. And in the isolation of South America, cut off from other continents by oceans, they evolved into predators of astonishing size and ferocity. These were the phorusrhacids, better known as the terror birds. And for millions of years, they stood at the top of the food chain, apex hunters whose hooked beaks and long legs made them the nightmares of the mammalian world. The terror birds were unlike anything alive today. Some stood over 3 meters tall, their skulls alone nearly a meter long. Their beaks were hooked like those of eagles, but magnified to monstrous scale, capable of delivering bone-crushing blows. Their legs were built for speed, allowing them to sprint across plains in pursuit of prey. Their wings had shrunk to useless stubs, but they were not needed. These birds did not fly. They ruled the ground, stalking with the confidence of predators who had no equals. Imagine a world where the shadow of a bird meant not a song in the trees, but a death sprint on the ground. The isolation of South America was key to their dominance. While North America and Eurasia saw the rise of mammalian predators like creodonts and later true carnivorans, South America had no such competition. Mammals there were mostly herbivorous or small omnivores. Into that vacuum stepped the terror birds, evolving into a spectrum of forms. Some were small, chicken-sized scavengers. Others, like the titanic kelincan, were towering predators capable of preying on dog-sized mammals. In their diversity, they mirrored the roles once played by theropod dinosaurs: sprinters, ambushers, scavengers, and killers. Their hunting strategies were formidable. Fossil evidence of their skulls suggests they used their massive beaks like hatchets, striking downward to stun or kill prey. Once their victim was incapacitated, they could tear it apart with sharp edges of keratin and swallow large chunks whole. Their long legs gave them speed over open terrain, meaning few mammals could outrun them. And their size alone was intimidating. An animal that towered over most mammals of the time, its eyes fixed forward, its stride relentless. For millions of years, they were the terror of South American plains and forests. Other giant birds also rose in different parts of the world during the Paleocene and Eocene. In Europe, Gastornis, once called diatrima, was a massive flightless bird nearly 2 meters tall. For years, paleontologists debated whether it was a predator or a herbivore. Its beak was powerful, its size imposing, but evidence now suggests it may have eaten tough plants more than flesh. Still, in appearance it echoed the terror birds of South America, a reminder that in multiple places evolution saw opportunity for giant birds to dominate the land. Why birds? The answer lies in legacy. Birds were the only dinosaurs to survive the extinction, and they inherited many of the adaptations that had made their ancestors dominant for over 150 million years. They were fast, agile, and intelligent. They laid eggs that could hatch quickly, and their bodies could adapt to varied diets. When mammals were still small and limited, birds already had the evolutionary toolkit to expand. In South America, with its isolation, they took that inheritance and magnified it, becoming the predators mammals had not yet evolved to challenge. Their reign lasted for tens of millions of years. Terror birds hunted the strange ungulates of South America, herbivores with hooves, some with trunks, others with odd teeth. They coexisted with giant armadillos, ground sloths, and marsupials, shaping ecosystems with their predatory dominance. They were so successful that even as mammals grew larger and more diverse, the birds retained their power. Fossils show them thriving from the Paleocene through the Miocene, their legacy stretching well beyond the age when most Paleocene experiments had vanished. The end of their dominance came not through failure, but through contact. When South America eventually connected to North America during the Great American Interchange about 3 million years ago, mammalian carnivores like big cats, bears, and canids moved south. The terror birds, though still formidable, now faced predators evolved in a different crucible. Social hunters, stealthy stalkers, animals that killed with claws and teeth rather than beaks. Gradually, the birds faded, their role as apex predators taken over by mammals. Yet for millions of years they had shown that birds could rule the land as fearsomely as dinosaurs ever had. To picture a Paleocene or Eocene landscape ruled by terror birds is to see a world of primal tension. Herds of ungulates grazing nervously under flowering trees, their ears twitching for the sound of pounding steps. A giant bird stalking through the grass, head bobbing, eyes locked on its target. A sudden burst of speed, a strike of the beak, a mammal felled in seconds. Then silence as the bird consumes its kill while smaller scavengers wait their turn. It was not the world of raptors and tyrannosaurs, but it carried their echo in feathers and flesh. The rise of terror birds underscores a broader truth about evolution. Power is not bound to one lineage. Dinosaurs ruled, then fell. Mammals rose, but in places birds seized dominance instead. Intelligence, size, speed, and weaponry can take many forms: claws, teeth, or beaks. What matters is opportunity, and in South America, birds seized it. They remind us that the legacy of the dinosaurs did not truly end at the Cretaceous boundary. It continued, feathered, swift, and deadly, reshaping ecosystems long after reptiles were gone. In the balance of predator and prey, the terror birds were indispensable. They kept herbivore populations in check, preventing overgrazing. They forced mammals to adapt, to evolve swiftness, awareness, and sometimes armor. They contributed to the evolutionary arms race that pushed mammals toward greater intelligence and diversity. Their reign, though eventually broken, was not wasted. It forged ecosystems that were sharper, tougher, and more resilient. To stand before a terror bird would be to see not just a predator, but a lineage reaching back to the age of dinosaurs. Its feathers were a reminder of raptors, its beak a weapon honed by millions of years of survival. Its stride carried the echoes of ancient theropods. In it, the past and present blended, a bird, but also a shadow of the world that had ended in fire and ash. The Paleocene and Eocene were not quiet recoveries, but bold reinventions. Birds grew into predators of towering size. Mammals grew into giants of fur and bone. Reptiles lingered as snakes and crocodiles of monstrous form. And in each of these the world was rewritten. Life had been nearly destroyed, but in its rebuilding it showed imagination as fierce as it was unrelenting. By the time the Eocene gave way to the Oligocene, the wild experimentation of the Paleocene was beginning to settle. The world had been reborn in fire and shadow after the asteroid, and for tens of millions of years life had tried every shape it could imagine. Giant snakes, terror birds, bizarre hoofed mammals, and early primates with grasping fingers. But evolution does not preserve every sketch. Many of the Paleocene's strangest creatures were short-lived, disappearing as climates shifted, continents drifted, and competition intensified. What endured were the lineages that would become the foundations of the modern world. The story of the later Paleocene and Eocene is the story of narrowing possibility, of life converging toward the families of animals, plants, and ecosystems that still surround us today. The Earth itself was a restless architect in this transformation. Tectonic plates continued their slow collisions and separations, redrawing coastlines and opening new migration routes. India pressed into Asia, raising the first peaks of the Himalayas. The Atlantic widened, changing ocean currents. Australia drifted farther from Antarctica, carrying marsupials into isolation. Each shift inland reshaped climates and biomes, carving out new opportunities and closing off old ones. Evolution moved in step, rewarding adaptability and punishing specialization. One of the most important trends was the cooling of the climate. The greenhouse warmth of the Paleocene and early Eocene, which had supported lush forests from pole to pole, began to fade. Carbon dioxide levels declined, whether through changes in volcanism, plant growth, or ocean circulation, and temperatures fell. Polar regions that had once hosted crocodiles and palm trees grew colder. Ice began to appear in Antarctica. Grasslands began to spread where forests once dominated. These shifts forced animals and plants to adapt to more open, seasonal environments. The mammals responded with remarkable resilience. The bizarre condylarths of the Paleocene gave way to more familiar ungulates, ancestors of horses, camels, antelopes, and cattle. Their teeth sharpened into forms suited for grazing tougher vegetation, their legs lengthened for faster running across open plains. Predators evolved in turn. Creodonts, once dominant, began to fade, replaced by true carnivorans, the ancestors of cats, dogs, and bears. These hunters had more efficient jaws, stronger senses, and greater adaptability, traits that would ensure their dominance for the rest of the age of mammals. The predator-prey balance of the modern world was taking shape. Primates, too, continued their ascent. In the Eocene, they diversified into a wide array of forms, including the ancestors of lemurs, monkeys, and apes. With larger brains and more complex social structures, they thrived in forests that still stretched across much of the globe. Their reliance on fruit, leaves, and insects tied them to ecosystems shaped by flowering plants. The partnership between primates and forests deepened, preparing the way for the eventual rise of hominins millions of years later. The lineage that began with squirrel-sized creatures in the Paleocene canopy was branching into new directions, setting the stage for intelligence and culture far in the future. Birds, while no longer the uncontested rulers of predation in most regions, diversified as well. Many lineages of modern birds appeared, from waterfowl to songbirds. The terror birds of South America retained their dominance, but elsewhere, mammals were taking over top predatory roles. The skies and forests filled with bird species that resemble what we know today, their calls and songs more familiar than the haunting silence of giant hunters. Reptiles persisted too, though their glory days of gigantism were waning. Titanoboa vanished as climates cooled, its massive body unsustainable in cooler conditions. Crocodiles retreated from high latitudes, surviving in tropical and subtropical zones where warmth persisted. Turtles remained diverse, some reaching large sizes, but none as enormous as their Paleocene relatives. The age of reptiles had truly passed. The age of mammals was in full command. The oceans also shifted toward modernity. Early whales, once awkward semi-aquatic creatures, became fully marine. By the late Eocene, species like Basilosaurus, swam as apex predators, stretching over 50 feet in length. Other whales began to experiment with filter feeding, laying the groundwork for baleen whales that would one day rival entire ecosystems in size and abundance. Sharks diversified alongside them, and fish populations grew richer as marine ecosystems stabilized after the extinction's collapse. By the close of the Eocene, the oceans looked more like the seas we recognize today, dominated by mammals and fish rather than reptiles. Plants mirrored these changes. Flowering plants continued their dominance, expanding into every biome. Grasses appeared and began their slow rise, preparing for the great grassland expansions of later epochs. Forests remained important, but their composition shifted, favoring species adapted to cooler and drier conditions. Wetlands expanded in some regions, supporting amphibians, birds, and mammals. Plants were not passive. Their spread and retreat reshaped animal evolution as profoundly as predators and prey did. The narrowing of diversity also meant extinctions. Many of the Paleocene's oddities, creodonts, brontotheres, early primate lineages, giant penguins, vanished by the Oligocene. Climate change, competition, and specialization all played roles. Yet these losses were part of evolution's process. Experiments ended, but the survivors carried forward traits refined by millions of years of trial. By the time the modern world emerged, the winners were those who had learned to adapt broadly: ungulates that could graze or browse, predators with flexible hunting strategies, primates with intelligence and social bonds. The transformation toward the modern world was not abrupt, but gradual, a long tapering of evolutionary extravagance into something more familiar. The bizarre gave way to the practical, the experimental to the enduring. What had once been a planet of strange beasts became a planet of recognizable families, still strange in their own right, but less alien to our eyes. The stage was set for the ice ages, for human ancestors, for the ecosystems we now call home. To walk across an Eocene plain near its end would feel startlingly modern compared to the Paleocene swamps. Herds of grazing ungulates dotted the landscape. Carnivorous mammals stalked them with stealth and cunning. Birds flew overhead, many resembling modern species. Whales sang in nearby seas, their songs carrying across waters once ruled by reptiles. Forests still thrived but had edges giving way to grasslands. The balance of predator and prey, of plant and herbivore, of sea and shore was recognizably the one we live in today. The Paleocene and Eocene were the bridge between catastrophe and continuity. They began with chaos, with ash, and with survivors scratching out existence in ruins. They ended with order, with systems familiar to us, with mammals, birds, and plants forming the backbone of modern biodiversity. The terror birds, the titanoboas, and the creodonts may be gone, but their time was not wasted. They tested the possibilities, and in doing so, they cleared the way for the enduring forms of life that followed. From the ashes of the dinosaurs came not only survival, but reinvention. By the close of the Paleocene and Eocene, the Earth was no longer a scarred battlefield of extinction, but a vibrant world preparing for its next chapters. The giants had been reimagined, predators reborn, primates had risen, and ecosystems had settled into balance. What we recognize today as the living world had its roots here, in the ages when life dared to try everything and then chose what would endure. The story of what happened after the dinosaurs did not end with the rise of mammals, the fading of terror birds, or the songs of whales echoing through the seas. Its final chapter is written in us. Every breath we take, every cell in our bodies, every habit of our species carries echoes of the Paleocene and Eocene, those millions of years when life rebuilt itself from ashes and dared to try again. What we are today is not separate from that time, but a continuation, the result of choices nature made in the shadows of extinction. The human body is a museum of this ancient history, Our grasping hands, with their 5 fingers and opposable thumbs, were shaped by tiny primates clinging to Paleocene branches. Their need to navigate canopies with precision gave us the dexterity to write, to sculpt, to build. Our forward-facing eyes, tuned for depth, trace back to those same creatures judging leaps among trees. Without that adaptation, we might never have developed the visual acuity to hunt, to read, to explore the stars. The intelligence we prize so highly began as survival in a fruit-filled canopy, where memory and awareness meant life or death. Our very metabolism owes much to the age of mammals. Warm-bloodedness, the ability to generate and regulate our own heat, was an advantage tested in the unstable climates of the Paleocene. Small mammals endured the long night after the asteroid because they could keep warm in burrows and dens, and that trait became a permanent gift. Today we eat and burn energy in cycles shaped by those ancient struggles, carrying forward the chemistry of survival from 60 million years ago. The ecosystems around us are also descendants of this age. The forests we walk through, whether temperate or tropical, are dominated by flowering plants that rose to prominence after the extinction. The fruits we eat, from figs to apples, are part of the evolutionary pact between plants and animals forged in the Paleocene, when birds and mammals first spread seeds in return for nourishment. The grasslands that feed our cattle and sustain billions trace back to the grasses that first appeared as forests receded in cooler climates. Even the oceans bear the mark of that transformation, filled with whales whose ancestors once walked on land. The predators and prey of the modern world, too, are echoes. Our dogs and cats descend from carnivorans who replaced the creodonts. Our horses and cattle are heirs to ungulates that grew and flourished in the Paleocene's aftermath. Even the shape of our fears, the sudden snap of a predator, the shadow overhead, the instinctive startle at a rustle in the grass, may be psychological fossils, remnants of the age when terror birds and snakes kept early mammals nervous and alert. Evolution does not only write in bones, it writes in instincts, in behaviors passed down as quietly as genes. We ourselves, as a species, are the ultimate echo. Humans are primates, descendants of those small canopy dwellers who took refuge after the dinosaurs fell. The intelligence that allowed us to split atoms and sail oceans is the flowering of seeds planted in those humid forests. Our social bonds, our reliance on cooperation and communication may trace to the grooming and calls of early primate groups learning to survive together. When we tell stories, when we sing, when we build societies, we are extending the same strategies that once kept tiny mammals alive under the canopy of flowering plants. Even our fragility ties us back. We are vulnerable to climate change because the climates of the Paleocene and Eocene shaped us to thrive within certain ranges of temperature and food supply. We are dependent on flowering plants and the insects that pollinate them, a system built in that distant age. We are tied to oceans shaped by whales and fish, to soils enriched by forests that spread in the Paleocene. Our survival is still entangled with the outcomes of that recovery. The Earth remembers, and we are part of that memory. The extinction that ended the dinosaurs is often described as the end of an era, but in truth it was also a beginning. The Paleocene and Eocene were not just interludes, they were foundations. They tested possibilities, discarded failures, and solidified the survivors into lineages that would endure for tens of millions of years. Without that age of reinvention, there would be no elephants, no whales, no primates, and no humans. The silence that followed the asteroid was not the silence of death, but the silence before a new song, one that still plays today. And perhaps the deepest echo of all is the reminder that life is resilient. Catastrophe can erase giants, but it also clears the way for new beginnings. The dinosaurs were gone, yet birds survived. Mammals, once tiny and overlooked, rose to prominence. Forests regrew, seas refilled with predators, and ecosystems became richer than before. Every flower in a garden, every mammal grazing in a field, every bird in the sky is proof that extinction is never the end of the story, it is only a chapter. To reflect on the Paleocene and Eocene is to reflect on ourselves. We carry their legacy in our bones, in our instincts, in the world we inhabit. The giants of that age may be gone, but their influence remains, shaping every corner of our existence. We are, in a sense, children of that recovery, heirs to a resilience older than memory. So the question of what really happened after the dinosaurs went extinct is not only about titanoboa, terror birds, or primates in the canopy, it is about us. The ashes became soil, the soil grew forests, the forests raised primates, and from them came humanity. We are the echoes of that age, the living testament to life's refusal to stop. And as long as we breathe, the story of the Paleocene and Eocene continues, not only written in fossils, but written in us.